Welcome to 60 Days to Master Python. In this course, you will learn everything from the basics of Python to advanced concepts all within 2 months. Whether you are starting with your programming journey or looking to sharpen your skills, this course is designed for you. Let's dive in. Congratulations on starting your Python learning journey. Over the next 60 days, we will guide you step by step from understanding Python's syntax to building real-world projects. Get ready to learn something exciting each day and apply what you have learned with mini projects. So, what will we learn? In the first 2 weeks, we will cover the fundamentals, Python syntax, loops, functions, and control flow. By week 3, we will dive into object-oriented programming and error handling. Then we will explore advanced topics like web development, data analysis, machine learning, and more. Every week ends with a mini project to help you apply your knowledge in practical ways. This course is designed for beginners, intermediate learners, and anyone interested in taking their Python skills to the next level. If you are new to Python, you will start with the basics. If you are already familiar with some concepts, we will take you deeper into advanced topics like machine learning and web development. Ready to level up? Let's go. Our course is structured with daily lessons that take just 15 to 30 minutes. Every week, we will focus on different Python concepts. You will finish each week with a mini project to help solidify your learning. And by the end, you will complete a Capstone project to showcase your skills. Before we start coding, there are just a few things you will need: a computer, internet access, and Python installed on your system. Don't worry, on day 1, we will guide you through the installation process. You just need the motivation to learn and create. Why should you learn Python? Well, it's one of the easiest programming languages to learn with simple and readable syntax. It's also incredibly versatile, used in web development, AI, data science, automation, and much more. Plus, there's a high demand for Python developers in today's job market. By learning Python, you are opening doors to endless opportunities. Excited to begin? On day 1, you will get an introduction to Python, learn what makes it so popular, and set up your environment. Then we will guide you through writing your very first Python program, the classic Hello World. Get ready to write some code. Now that you know what's ahead, let's start coding together. Take it one step at a time and don't worry if you don't get everything perfect right away. Remember, the key is consistency and we will be with you every step of the way. Here's a quote to keep you going. The journey of 1,000 miles begins with a single step. Every line of code you write brings you closer to mastering Python. Stay motivated, trust the process, and remember that every small step counts toward your success. Keep pushing forward. That's it for the introduction. You are all set to start day 1. Don't forget to like, subscribe, and leave any questions or thoughts in the comments below. Let's dive in and start your Python journey today. Welcome to the first day of our Python programming course. Today we will be diving into an introduction to Python, covering its features, installation, environmental setup, and writing your very first Python program. Let's get started. So what exactly is Python? Python is a high-level interpreted programming language that's known for its simplicity and readability. It's a favorite among beginners and experienced developers alike. Some key features of Python include its readable and concise syntax, which makes it easy to learn. It's an interpreted language, meaning your code is executed line by line and it's dynamically typed, so you don't need to declare variable types. Python supports object-oriented programming, making your code more modular and reusable. With a large selection of libraries and frameworks, Python is used in everything from web development to machine learning. Plus, it's cross-platform, meaning it runs on Windows, Mac OS, and Linux. Next, let's look at how to install Python. To get started, visit the official Python website at python.org. Download the latest version of Python 3.x for your operating system and run the installer. Be sure to check the box that says Add Python to Path during the installation process. Once installed, open your terminal or command prompt and then type python version to verify that Python was installed successfully. You should see the version number of Python that was installed. Now let's set up our development environment. An IDE or integrated development environment is a tool that helps you write, test, and debug your code all in one place. For Python, there are several IDEs you can choose from. PyCharm is a full-featured IDE that's great for beginners and advanced users. Visual Studio Code is a lightweight, customizable editor with support for Python through extensions. And if you are working with data science or prefer an interactive environment, Jupyter Notebooks is an excellent choice. To install these IDEs, go to their respective websites. For PyCharm, visit JetBrains' website and download the Community Edition. For Visual Studio Code, go to code.visualstudio.com and install it. Then add the Python extension from the marketplace. If you are using Jupyter Notebooks, you can install it via the command line using pip install notebook. Once installed, launch it by typing Jupyter Notebook in the terminal. Now for the fun part, writing your first Python program. The Hello World program is the traditional first program in any language. It simply displays the message Hello World on the screen. Here's the code: printf Hello World. The print function is a built-in Python function that outputs text to the screen. The text itself, Hello World, is a string and is enclosed in quotation marks. Once you have written the code, it's time to run your program. If you are using an IDE, simply click the Run button. In the terminal, you can run the program by typing python hello_world.py or python3 hello_world.py depending on your system configuration. Running this program will display Hello World on the screen, confirming that your setup is working correctly. Great job! On day 1, we have covered a lot of ground. You learned what Python is and why it's so popular. You installed Python and set up your development environment, and you wrote and ran your very first Python program, Hello World. In the next lessons, we will build on this foundation and dive deeper into Python programming. Stay tuned. Welcome to day 2 of our Python programming course. Today we will be covering the basics of Python syntax, including variables, data types, and operators. Let's dive right in. Let's begin with variables and data types. In Python, a variable is used to store a value. The great thing about Python is that you don't need to explicitly declare the type of a variable. Python automatically figures it out based on the assigned value. For example, you can create a variable called age and assign it to the value 25, like this. Here, age is an integer, name is a string, and height is a floating point number. Now let's look more closely at the different data types you will encounter in Python. There are a few basic types: integers, floating point numbers, strings, booleans. Integers are whole numbers like 25. Floating point numbers have decimals like 5.6. Strings are sequence of characters enclosed in quotation marks like Alice. Booleans represent logical values, either true or false. Here's an example. Now you have better understanding of how to create and assign values to variables. Next, let's talk about arithmetic operators. These operators are used to perform basic mathematical operations on numbers. The plus operator adds two numbers. The minus operator subtracts one number from another. The asterisk operator multiplies numbers. The divide operator divides numbers and gives a floating point result. The two backward slash operator performs integer division, discarding the decimal. The modulo operator gives the remainder of a division, and and the two asterisk is used for exponentiation or powers. Here is an example of the basic use of this operator. These operators allow you to perform basic calculations in Python. Moving on to comparison operators. These operators allow you to compare two values and return a Boolean result, either true or false. The double equal to checks if two values are equal. The not equal to checks if they are not equal. Greater than checks if one value is greater than another. Less than checks if one value is less than another. Greater than or equals to checks if a value is greater than or equal to another. Less than or equals to checks if a value is less than or equal to another. These operators are essential for making decisions in your program. Now let's explore logical operators. These are used to combine conditional statements and return a Boolean result. The AND operator returns true if both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator inverts the result, so true becomes false and vice versa. Here's an example. These operators help control the flow of your program based on conditions. Next, let's talk about typecasting. Sometimes you may need to convert one data to another. This is where typecasting comes in. You can use functions like int to convert a value to an integer, float to convert a value to a floating point number, string to convert a value to a string. For example, in the below Python code, x is assigned the value string 25. We can convert this string into an integer by using the int function. Typecasting ensures that your variables are in the right format for your calculations or operations. To summarize, what we have learned today, we have covered variables and data types, including integers, floats, strings, and booleans. We have explored arithmetic, comparison, and logical operators. We have also seen how to perform typecasting to convert between data types. Now it's time to practice. Try implementing simple expressions using these operators. Create variables of different types and use them in calculations. This will solidify your understanding of Python syntax and operations. Welcome to day 3 of our Python programming journey. Today we will be diving into control flow and focusing on conditionals. How to make decisions in your Python programs. Conditionals allow us to make decisions based on certain conditions in our programs. They help guide the flow of execution by determining which block of code should run. In Python, we use if, else, and elif statements to control the flow of our program based on conditions. Let's start with the if statement. The if statement is used when we want to execute code only if a particular condition is true. The syntax is simple. You write if followed by the condition, then a colon, and finally the block of code you want to execute if the condition holds true. For example, if age is greater than or equal to 18, you could print that the person is an adult. The else statement. Next, we have the else statement. This is paired with an if statement and is used to define what should happen if the if condition is false. In the example here, if the person's age is not 18 or older, the program will print that they are not an adult. The elif statement, in short for else if, comes in handy when you need to check multiple conditions. If the initial if condition is false, Python moves to check the elif condition. You can use as many elif statements as you need. For example, if someone is under 18, they might be classified as a minor, and if they are 18 or above but less than 21, they might have different privileges, like being able to vote but not drink alcohol. Now let's talk about Boolean expressions. A Boolean expression is simply a condition that evaluates to either true or false. For example, x equals to y checks if x is equal to y, while x not equals to y checks if they are not equal. Boolean expressions are also used with logical operators like AND, OR, and NOT to combine conditions. These expressions allow us to create more complex decision-making structures. In this example, we check if both conditions are true using the AND operator. If x is greater than y and also equal to 10, we print a message. Similarly, we use NOT to inverse the Boolean value of the condition. If x is not equal to y, the message is printed. Sometimes you may need to make decisions within decisions. This is called nesting conditionals. In a nested if statement, you place one if statement inside another. For example, if someone is old enough to enter an event, you can further check if they have a ticket. If they do, they can enter. Otherwise, they are told they need a ticket. Now let's combine what we have learned with user input. In this example, we ask the user for their age and check if they are eligible to vote. The input function captures user input as a string, so we need to convert it to an integer using int. Based on the input, the program will print whether the person is eligible to vote. Let's put your skills to the test with a few practice exercises. First, you can create a program to check if a number is even or odd. Second, write a program that checks the temperature and determines if it's hot, cold, or moderate. And lastly, write a program that asks for the user's age and prints which age group they belong to. To conclude, conditionals are an essential part of Python programming. Mastering if, elif, and else allows you to write dynamic programs that respond to different situations. Keep practicing writing conditional statements, and soon you will be able to create more interactive and intelligent programs. Thanks for joining me and happy coding. Welcome to day 4 of our Python course. Today we will be covering loops in Python. Loops are a fundamental concept in programming, allowing us to repeat tasks efficiently. Let's dive right in. Loops in Python enable repetitive execution of code, which can save us from writing repetitive instructions. Whether we are iterating over a sequence like a list or repeating actions based on a condition, loops are incredibly powerful. They help to keep our code clean, concise, and efficient. First, let's look at the for loop. This loop is used to iterate over a sequence such as a list, string, or range. Here's the syntax. We use the keyword for followed by a variable name, then that will take each value of the sequence, and then a colon. Inside the loop, we write the code that we want to execute for each item in the sequence. Here's an example of a for loop in action. We have a list of fruits: apple, banana, and cherry. Using a for loop, we iterate through this list, and for each fruit, we print its name. When we run this code, the output will be each fruit printed on a new line: apple, banana, and cherry. Next, let's look at range, a built-in Python function often used in for loops. It generates a sequence of numbers which we can use to loop through a set of number of iterations. The syntax includes three parts: start, stop, and step. By default, the range function starts at 0 and steps by 1, but you can customize it to fit your needs. Here's an example. This for loop counts from 1 to 5 using range 1, 6. The loop will print numbers 1, 2, 3, 4, and 5, as we specified that the loop should start at 1 and end before 6. This is a great way to repeat a task a set number of times. Next, let's explore the while loop. Unlike the for loop, which iterates over a sequence, the while loop continues to execute as long as a specified condition remains true. It's ideal for situations where we don't know the exact number of iterations upfront. As long as the condition is true, the loop keeps running. Here's an example using a while loop. In this case, we start with I equal to 1. As long as I is less than or equal to 5, the loop will print I and increment I by 1 each time. Once I exceeds 5, the loop ends. In Python, we can control the flow of our loops using break and continue statements. The break statement exits the loop entirely, while the continue statement skips the current iteration and proceeds to the next one. These statements are useful when you need to alter the flow of the loop based on certain conditions. Here's an example using the break statement. In this loop, we check if I equals 5, and if so, we break out of the loop. The loop will print 1 through 4, but once it hits 5, it stops early due to the break. On the other hand, the continue statement skips the current iteration and moves to the next one. In this example, when I equals 3, the loop skips printing 3 and moves directly to the next iteration, printing 1, 2, 4, and 5. Now let's talk about nested loops. A nested loop is a loop inside another loop. This is particularly useful when working with multi-dimensional data, like lists of lists. The inner loop will run completely for each iteration of the outer loop. In this example, we have two loops, one for I and one for j. The outer loop iterates over values 1 through 3, and for each value of I, the inner loop iterates over values 1 to 3 as well. The output shows every combination of I and j. In some cases, we may want a loop to run indefinitely until a specific condition is met. This is called an infinite loop. You can use a while true loop, but it's crucial to control the flow with a break statement to avoid getting stuck in the loop forever. Finally, let's wrap up with some practice exercises to reinforce what we have learned today. Try creating a countdown program that prints numbers from 10 to 1 followed by blast off, or implement a guessing number game where the user tries to guess a number between 1 and 20, receiving hints like too high or too low until they guess correctly. This concludes day 4 of our Python course. We have covered the basics of loops in Python, including for loops, while loops, and how to control loop flow using break and continue. In the next session, we will dive deeper into more advanced Python concepts. Thanks for joining and happy coding. Welcome to day 5 of our Python journey. Today we will dive into functions. Functions are essential building blocks in programming that allow us to organize code, improve readability, and reuse logic efficiently. Let's start by understanding how to define a function in Python. The syntax is simpler. You use the keyword def followed by the function name, parenthesis for parameters, and a colon. Then you define the body of the function. Finally, you use return to send a result back to the caller. Functions can also be defined without parameters. Here we have a simple function called greet that does not require any input but prints a welcome message when called. You can use such functions for tasks like displaying information or performing a fixed operation. Now let's look at functions with parameters. Parameters allow us to provide input to function, making it more dynamic. In this example, the function addNumbers takes two numbers and returns their sum. Notice how we pass values when calling the function. Functions don't just execute tasks, they also return values. In the square function, we take a number as input and return its square. The result is then stored in a variable. Using return allows us to send values back from a function to wherever it was called. Did you know that functions can return multiple values? This is done by returning them as a tuple. In the swap function, we return two values b and a, which we unpack into variables x and y. This makes functions more flexible and powerful. Sometimes you may want a function to have default values for parameters. This is where default arguments come in. In the greet function, if no name is provided, it defaults to guest. This can make your function more user-friendly and adaptable. Python also allows keyword arguments where you specify the name of the parameter when calling the function. This improves readability and ensures that the arguments are passed correctly. For example, we are using introduce with name and age specified by their names. With variable length arguments, Python provides even more flexibility. Using *args, you can pass a variable number of non-keyword arguments. Similarly, *kwargs lets you pass a variable number of keywords arguments. This is perfect for situations where you don't know how many arguments might be passed to your function. Let's talk about the scope of variables in functions. Local variables are defined inside a function and aren't accessible outside. However, global variables are defined outside of any function and can be accessed by any part of your program. Keep this in mind when designing your code. Recursion is an advanced concept where a function calls itself to solve a problem. In this example, the factorial function calls itself until it reaches the base condition. Recursion is a powerful tool, but make sure you define a base case to avoid infinite loops. Now that we have covered functions in depth, it's time for some practice. Try writing a function to calculate the factorial of a number using recursion, or create a function that takes a list and returns the highest number. These exercises will help reinforce the concepts you have learned today. To further sharpen your skills, consider creating a mini project. For example, build a calculator with different functions for operations like addition and subtraction. Or create a number guessing game where functions help structure the game logic. These projects will give you hands-on experience with everything you have learned about functions. That's it for today's lesson on functions in Python. Functions are a core part of programming, and mastering them a more efficient will help you a more efficient and organized coder. Keep practicing and we will see you in the next lesson. Welcome to day 6 of our Python programming course. Today we will explore Python's powerful built-in data structures. By the end of this lesson, you will understand how to efficiently store and manipulate collections of data. Let's dive in. First up, we have lists. A list in Python is an ordered collection of items. Lists are mutable, meaning you can change their content. For example, we can create a list like this. Lists are great for storing data that you need to access and modify regularly. Let's look at some common operations on lists. You can access elements using an index like mylist0, which gives you the first element. You can also modify elements. For example, mylist2 is equals to 10 will change the third item in the list. To add new items, you can use the append method, and to remove an item, use remove. You can also use pop to remove the last item. When working with lists, you can loop through the items with a for loop. Here's an example. For item in my list, print item, and for slicing, you can grab a portion of the list like this. Sublist equals to mylist 1:4. This returns a new list with items from 1 to 3. Next, let's talk about tuples. A tuple is also an ordered collection, but unlike lists, tuples are immutable. This means once a tuple is created, you cannot change its content. Here's an example of tuple. My tuple is equals to 1, 2, 3, 4, and 5. Tuples are useful when you need a collection of data that should not be modified. Similar to lists, you can access elements in a tuple with an index. However, since tuples are immutable, you can't modify or add new items, but you can slice a tuple like so. In the example, subtuple equals to my tuple 1:3. This will give you a portion of the tuple without changing the original. Now let's look at sets. A set is an unordered collection of unique items. If you try to add duplicate elements, they will automatically be ignored. Here's an example of a set. Sets are great when you need to store a collection of items and don't care about the order, but you want to avoid duplicates. With sets, you can add elements using the add method and remove them with a remove or discard. You can also perform set operations like union, intersection, and difference. For example, to combine two sets, you can use the pipe operator like this. Union equals to my set, pipe, another set. To iterate over a set, you can use a simple for loop. For item in my set, print item. This allows you to loop through each element in the set. Finally, let's talk about dictionaries. A dictionary is an unordered collection of key value pairs. It's useful when you need to associate with a unique key with a value. Here's an example. You can store various types of data using dictionaries, and they are especially powerful for looking up values based on a key. In a dictionary, you can access values by referring to their keys like this. Name equals to my dictionary name. You can also modify values, add new key value pairs, and remove items using tail. Dictionaries have several useful methods like dot keys, dot values, and dot items. You can use these methods to access the keys, values, or both from a dictionary. For example, in the Python code below, for key, value in my dictionary, print key, value. Let's now look at some practical examples. For lists, you can create a simple to-do list like this. To-do list equals to buy groceries, write homework, clean the house. To-do list dot append read a book, print to-do list. For tuples, let's say you are storing geographic coordinates. Here's an example. This tuple represents the latitude and longitude of New York City. For sets, you can use them to remove duplicates from a list. Here's an example. The set will automatically discard the duplicate values. And for dictionaries, let's say you are storing student grades. This allows you to easily manage and retrieve data associated with each student. To summarize, today we have covered Python's fundamental data structures like lists, tuples, sets, and dictionaries. Each data structure has its unique characteristics and use cases. Lists are mutable, tuples are immutable, sets store unique items, and dictionaries store key value pairs. Mastering these will make it easier to work with data in Python. Welcome to day 7 of our Python course. Today we will focus on practice session where we apply what we have learned so far. We will be working on 2 mini projects, a basic calculator and a number guessing game. These projects will help reinforce key concepts like functions, loops, conditionals, and user input. Our first mini project is a basic calculator. The goal is to create a program that performs basic arithmetic operations like addition, subtraction, multiplication, and division. You will need to write separate functions for each operation and use loops to allow users to perform multiple calculations. You will also need conditionals to choose the correct operation and handle errors, such as division by 0. Users will input numbers and choose the operation they want to perform. Here's the basic workflow of our calculator. First, display the available operations, addition, subtraction, multiplication, and division. Then ask the user to input 2 numbers. Based on the user's choice, you will perform the selected operation and display the result. Finally, prompt the user if they want to continue with another calculation or exit the program. Here's an example of how you can write the code for the calculator. The program defines functions for each operation: add, subtract, multiply, and divide. Inside the main loop, the user can select an operation, input 2 numbers, and see the result. If the user chooses to divide by 0, we handle that error and display a message. Now let's move on to our second mini project, a number guessing game. In this game, the computer randomly selects a number between 1 and 100, and the user has to guess it. After each guess, the program will tell the user if their guess is too high, too low, or correct. This project is a great way to practice using loops and conditionals. The workflow for the number guessing game is simple. First, the program randomly selects a number between 1 and 100. Then the user enters a guess. After each guess, the program checks whether the guess is too low, too high, or correct. The loop continues until the user guesses the correct number. Here's an example of the code for the number guessing game. We use Python's random module to generate the secret number. A while loop repeatedly asks the user for their guess, providing feedback after each guess. When the correct number is guessed, the game ends and the program congratulates the user. Here are some additional considerations. You can customize the calculator by adding more advanced operations like square roots or exponentiation. Similarly, for the number guessing game, you could increase the range of numbers, for example, allowing the user to guess between 1 and 1000. Good programming practices like using functions to organize your code and handling edge cases such as invalid inputs are key to creating a clean and effective program. By the end of these projects, you should have reinforced key concepts like functions, conditionals, loops, and user input. You will also have gained practical experience in building a simple Python program. These skills will serve as a foundation for more advanced projects as we move forward in this course. Great job! You have now completed the practical session for day 7. These mini projects will help you become more comfortable with Python and prepare you for more complex tasks in the future. Keep practicing and see you in the next session. Welcome to day 8 of our object-oriented programming course. Today we will dive into lists, an essential data structure in Python. We will cover everything from basic list operations to advanced techniques like list comprehension. Let's start with the basics. A list is an ordered collection of items in Python. Lists are flexible. They can contain elements of various data types like numbers, string, or even other lists. For example, you can create a list like this. My list equals to 1, 2, 3, Python. As you can see, this list contains both integers and a string. Now let's explore some common list methods that will help us manipulate lists efficiently. We can use methods like .appendX to add an element to the end of a list, or .insert I, x to insert an element at a specific position. If we need to remove an item, .removeX will do that, and .pop_i allows us to remove an item at a given index. Don't forget about .sort to arrange list items in order, and .reverse to reverse the order of elements. Slicing is another powerful feature in Python lists. You can extract a portion of a list using the slice syntax. List start stop step. For example, my list 1:4 gives us elements from index 1 to 3. You can also slice with a step like my list 2, which will return every second item from the list. Remember, slicing does not change the original list. It returns a new one. Next, let's talk about nested lists. A nested list is a list that contains other lists as elements. For example, nested list equals to containing the lists 1, 2, 3, 4 and 5, 6. You can access elements within nested lists by using multiple indices. For instance, nested list 0 gives us the first list 1, 2 and nested list 0, 1 gives us 2. When working with nested lists, you might need to iterate through both the outer and inner lists. You can use a nested loop for this. Here's an example. For each sublist in the nested lists, loop through each item in that sublist and print the item. This allows you to access every element, no matter how deeply nested it is. Let's move on to list comprehension, a concise way to create lists based on existing iterables. The syntax is simple: expression for item in iterable if condition. For instance, x asterisk asterisk 2 for x in range 5 generates the squares of numbers from 0 to 4, producing 0, 1, 4, 9, and 16. List comprehension makes code more readable and efficient. You can also use list comprehension with conditions. For example, x for x in range 10 if x modulo 2 equals to 0 will generate a list of even numbers between 0 and 9. And you can even use list comprehension to create nested lists like x for x in range 3 for y in range 2, which creates 0, 1, 2 and 0, 1, 2. Now it's time for you to practice what we have learned today. Here are some exercises for you. Create a list and perform methods like append, remove, and sort, and also try slicing the list. Work with a nested list and iterate through it to sum all the numbers. Use list comprehension to find numbers divisible by 3 in a range and create a multiplication table. For your mini project, we will build a simple to-do list app. We will use lists to hold tasks and dictionaries to store additional details, like the task name, due date, and status. Here's an example of a task stored in a dictionary. This will help you get comfortable with combining lists and dictionaries. To summarize, today we have learned that lists are an incredibly versatile data structure in Python. We explored various list methods, slicing techniques, and how to work with nested lists. We also saw how list comprehension can make our code more concise and readable. Make sure to practice these concepts as they are fundamental to Python programming. Welcome to day 9 of our course. Today we will be learning about tuples in Python. A tuple is an immutable, ordered collection of elements. Unlike lists, which are mutable, tuples are used when you want to store data that should not change after creation. Tuples are defined using parentheses as opposed to square brackets for lists. Let's start by creating tuples. A tuple can be created by placing elements inside parentheses. For example, my tuple equals to 1, 2, 3 creates a tuple with 3 elements. Tuples can also be empty or have a single element. An empty tuple is defined as empty tuple equals to only the parentheses. And a tuple with a single element looks like this. Single tuple element equals to 1, comma. The comma is necessary when there's only one element. You can access elements of a tuple using indexing, just like lists. Remember, indexing starts from 0. For instance, my tuple 0 will return 1. Negative indexing allows you to access elements from the end, like my tuple -1 will return 3. Tuples support several operations. For instance, you can concatenate two tuples using plus operator. If we have tuple 1 equals to 1, 2 and tuple 2 equals to 3, 4, concatenating them results in 1, 2, 3, 4. You can also repeat tuples using the asterisk operator. For example, 1, 3 asterisk 3 results in 1, 2, 1, 2, 1, 2, repeating the elements 3 times. One of the powerful features of tuples is tuple unpacking. You can unpack a tuple into individual variables. For instance, if you have coordinates equals to 4, 5, you can unpack it into x, y equals to coordinates. So x equals to 4 and y equals to 5. Tuples can also be nested, allowing for nested unpacking. For example, data equals to 1, 2, 3, 4 can be unpacked as a, b, c, d equals to data, resulting in a equals to 1, b equals to 2, c equals to 3, and d equals to 4. Tuples have a few built-in methods that can be quite useful. For example, count returns the number of times an element appears in the tuple. So for my tuple equals to 1, 2, 3, 1, 1, my tuple.count1 will return 3. Another method is index, which returns the index of the first occurrence of an element. For example, my tuple.index2 will return 1. One of the key characteristics of tuples is their immutability. Once a tuple is created, you cannot modify its elements. If you try to change an element like list, like my tuple 1 equals to 4, it will raise a type error. This immutability makes tuples efficient for storing fixed collections of data. Tuples are often used for returning multiple values from a function. For example, you can define a function getMinMax values that returns both the minimum and maximum values as a tuple. Tuples are also useful when you need to assign multiple variables at once. You can do this with a single line a, b, c equals to 10, 20, 30. Now let's compare tuples to lists. Tuples are immutable, meaning their contents cannot be changed after creation. On the other hand, lists are mutable and can be modified. In terms of performance, tuples are generally faster than lists, especially when used for fixed collections of data. So use tuples when you want to store data that should not change, and lists when you need to modify the data. One advanced use of tuples is that they can be used as dictionary keys. Since tuples are immutable, they are hashable, which allows them to be used as keys in dictionaries, unlike lists which cannot. For example, you can have a dictionary like myDict equals to 1, 2 value, where key is a tuple 1, 2. To help reinforce what we have learned today, here are a few practice exercises. Tuple unpacking exercise. Create a tuple of 3 elements and unpack them into separate variables. Dictionary with tuples as keys. Create a dictionary using tuples as keys. Function return tuple. Write a function that returns the largest and smallest values in a list. Practice immutability. Try modifying a tuple to understand the concept of immutability. That's all for today's lesson on tuples. We have covered their definition, creation, operations, methods, and how they differ from lists. Practice the exercises and experiment with tuples to gain a deeper understanding. See you in the next lesson. Welcome to day 10 of our Python course. Today we will explore dictionaries in Python. A dictionary is a collection of key value pairs where each key is unique and maps to a corresponding value. Dictionaries are unordered and mutable, meaning their contents can be changed after creation. They can also store mixed data types, making them versatile for various use cases. Let's start by creating a dictionary. The syntax looks like this. myDict equals to key1 colon value 1, key2 colon value 2, key3 colon value 3. Here's an example. We can create a dictionary called student to store information like the name, age, and codes. Student equals to name colon June, age colon 20, course colon computer science. To access values, you use the key inside square brackets like this. Student name, which would return John. Now let's see how we can modify or update dictionaries. For example, we can change the age of the student by assigning a new value. Student age equals to 21. We can also add new key value pairs. Here we add the graduation year. Student graduation underscore year equals to 2024. To remove an item, we can use del or pop. For instance, del student course will remove the course key. Next, let's look at how to iterate through a dictionary. You can look through just the keys using student.keys, through just the values with student.values, or through both the keys and values using student.items. For key comma value in student.items, print f key colon value. This will print each key along with its corresponding value. Python dictionaries come with several useful methods. For instance, clear removes all items from the dictionary. The copy method returns a shallow copy of the dictionary. If you want to safely access a key without causing an error, use get. If the key does not exist, it will return none. To get all the keys, values, or key value pairs, you can use keys, values, and items respectively. Dictionaries can also be nested, meaning you can have a dictionary inside another dictionary. Here's an example. Employee equals to name colon Alice, details colon age colon 30, department colon HR. To access nested values, you simply change the keys like this. Employee, details, age, which will return 30. Now let's put what we have learned into practice with a mini project, a to-do list app. We will use a dictionary to store tasks and where each task has a unique ID along with attributes like the task name, description, and status. Here's how we can define the structure. Task is assigned an empty dictionary. Def add task, task ID, name, description. Task ID equals to name colon name, description colon description, status colon pending. This function adds a new task to the dictionary. Let's continue with our to-do list app. We can add functionality to update a task status. This allows us to manage tasks dynamically, adding, updating, and removing as needed. For your assignment, Today, create a dictionary of employees in your company. Include their name, position, and department. Then implement a function to retrieve all employees from a specific department. You can also experiment with dictionary methods like get and items to interact with the employee data. Here's a sample structure for the employees dictionary. That wraps up our lesson on dictionaries. We have covered their creation, modification, iteration, and some useful methods. Don't forget to practice with the to-do list app and the assignment to solidify your understanding. See you in the next lesson. Welcome to day 11 of our Python course. Today, we will be exploring sets in Python. A set is an unordered collection of unique elements, meaning it does not allow duplicates. For example, my set contains the values 1, 2, 3, 4, and 5. Let's dive deeper into what makes sets so useful and how we can work with them. So, why should we use sets? First, sets automatically eliminate duplicate elements. Sets don't maintain any order, which makes them perfect for situations where you just need to check for unique values. For example, if you convert a list like 1, 2, 2, 3, 3, 4 to a list, the result will be 1, 2, 3, 4, removing all duplicates. This makes sets particularly handy when you are working with large amounts of data. Now let's look at some common set operations. The union operation, denoted by a pipe symbol, combines the elements of two sets. For example, if you have set A as 1, 2, 3 and set B as 3, 4, 5, the union will be 1, 2, 3, 4, 5. Next, the intersection operation, denoted by ampersand, finds common elements between two sets. Using the same sets, set A and set B will return 3 as 3 is the only common element. Moving on to more set operations, the difference operation, denoted by a minus sign, returns elements that are in one set but not the other. For example, set A minus set B will give 1, 2 because these are elements in set A that aren't in set B. The symmetric difference, denoted by, gives elements that are in either set but not in both. So set A, set B will return 1, 2, 4, 5, which are elements exclusive to each set. Sets have several useful methods. The add method lets you add elements to a set. For example, mySet.add6 adds 6 to the set. The remove method removes an element from a set. But be careful if the element does not exist. It raises an error. For example, mySet.remove4 will remove the element 4 from the set. On to more set methods, the discard method is similar to remove, but it does not raise an error if the element is not found. For example, mySet.discard4 will remove 4 if it exists, but will do nothing if 4 isn't in the set. The pop method removes and returns a random element from the set. It's important to note that since sets are unordered, you can't predict which element will be popped. Finally, the clear method removes all elements from the set, effectively leaving an empty set. Sets also support set comprehension, a concise way to create sets. Just like list comprehension, you can use set comprehension to create a set from a sequence. For example, x asterisk asterisk 2 for x in range 6 will give 0, 1, 4, 9, 16, 25, which is a set of the squares of numbers from 0 to 5. Let's summarize what we have learned about sets today. Sets are unordered collections of unique elements, making them ideal for tasks like eliminating duplicates. We explored operations like union, intersection, difference, and symmetric difference. We also saw some set methods such as add, remove, discard, pop, and clear. Finally, we learned how to use set comprehension for more compact code. These tools will help you work efficiently with sets in Python. Welcome to day 12 of our Python course. In today's lesson, we will dive into the world of strings, covering strings methods, formatting, and manipulating techniques to help you become proficient with handling text data in Python. Let's start by understanding what a string is. A string in Python is simply a sequence of characters enclosed in either single or double quotes. For example, hello or world. Strings are essential for working with text data, and they offer a wide variety of operations such as concatenation, slicing, and formatting. One common operation with strings is concatenation, which means combining two or more strings. In Python, you can concatenate strings using the plus sign. For example, let's say we have two strings, hello and world. By combining them with a space in between, we get hello world. It's that simple. Another important operation is string slicing. Slicing allows us to extract a portion of a string. We do this by specifying the start and end indices. For instance, if we have the string hello world and we want to extract hello, we can use slicing text 0:5. Here's a great way to grab specific parts of your strings. Now let's talk about string formatting. Python offers several ways to format strings. One way is using the format method. For example, if we have a variable name set to John, we can use the format method to insert it into a string hello.format name. This will output hello John. A more modern way is using f-strings, which allows us to embed variables directly in the string like this: f hello, name. String interpolation is another powerful technique, particularly with f-strings in Python. This allows you to embed expressions directly inside strings. For example, if you want to include the result of a calculation, you can write something like f the sum of a and b is a plus b. It's a convenient way to include dynamic content in your strings. Python strings come with many built-in methods. One useful method is upper, which converts all characters in a string to uppercase. For example, hello.upper would output hello with capital letters. Similarly, .lower converts all characters to lowercase. So hello.lower will give us result hello with all characters in lowercase letters. These methods are handy when normalizing strings. Another essential string method is strip, which removes any leading or trailing white space. For instance, if you have the string hello, using strip will result in hello. Also, replace is used to replace a string with another. For example, hello world.replace hello, Python will give you hello Python. Let's now look at the join method. This method is used to join a list of strings into a single string. Suppose you have a list like apple, banana, cherry. Using join with a space separator, dot join words would return apple, banana, cherry. It's a useful method for combining multiple strings into one. Python also offers several methods for testing and comparing strings. For example, starts with checks if a string begins with a specific substring, while ends with checks if it ends with one. For example, hello world starts with hello would return true. These methods are great for string validation. Similarly, find is a method that returns the index of the first occurrence of a string. If the substring is found, it returns -1. If the substring is not found, it returns -1. For example, hello world.find world will return 6 because world starts at index 6 in the string. Sometimes you need to include special characters in your strings, and that's where escape sequence comes in. For example, \n adds a new line, \t adds a tab, and / adds a backslash. So if you print hello \n world, it will appear as two lines, hello on the first and world on the second. Now it's your turn for a practice session. Your task is to write a Python program that converts a string to uppercase, replaces space with underscores, checks if the string starts with a vowel, and splits the string into words. This is a great way to test and reinforce your understanding of string operations. To summarize, today we have covered a range of string methods and operations including concatenation, slicing, formatting, interpolation, and common string methods like upper, lower, and replace. We also explored escape sequences and string testing. Keep practicing these concepts to build your confidence and skills with string manipulation in Python. Thank you for joining me today. Welcome to day 13 of our Python programming course. Today we will be diving into exception handling in Python. We will explore how exceptions work, how to manage them efficiently, and how to raise your own custom exceptions for better control over your programs. Let's start by understanding what exceptions are. Exceptions are errors that disrupt the normal flow of your program. They occur during the execution of your program, often causing it to crash if not handled properly. So, why should we handle exceptions? The main reason is to prevent your program from abruptly stopping. Instead, we can provide meaningful error messages to the user, improving the overall experience. In Python, we use the try, except, finally structure to handle exceptions. Here's how it works. The try block contains the code that might raise an error. The except block is where we catch and handle the exception if one occurs. The finally block runs no matter what, whether an exception occurred or not, allowing us to clean up resources or execute important final steps. Let's look at an example. In this code, we ask the user to enter two numbers and perform a division. If the user enters a non-numeric value, a value error will be raised. If the user tries to divide by 0, a zero division error will occur. Regardless of the error, the finally block will always print execution completed. This ensures that the program does not crash unexpectedly. Sometimes you might want to explicitly raise an exception in your program. You can do this by using the raise keyword followed by the exception type and an optional error message. In this example, we define a function to check if someone's age is under 18. If it is, we raise a value error, signaling that the age must be 18 or older. Here we call the check age function with an age of 16. Since 16 is less than 18, a value error is raised. We catch this exception in the except block and print a custom error message. Error: age must be 18 or older. Now let's talk about custom exceptions. In Python, you can create your own exception by subclassing the built-in exception class. In this example, we define a custom exception called negative number error, which is raised if a number less than 0 is processed. This gives us more control over how specific errors are handled. In this example, we attempt to process the number -5. Since negative numbers are not allowed, we raise the negative number error exception. This exception is caught in the except block, where we print the error message: error: negative numbers are not allowed. Sometimes you need to catch multiple types of exceptions in one block. You can do this by specifying a tuple of exception types in the except clause. In this example, we handle both value error and zero division error in one block. If either exception occurs, we print the corresponding error message. Exceptions in Python follow a hierarchical structure. The base class for all exceptions is base exception, followed by exception and various specific exceptions like value error, division zero error, and file not found error. Understanding this hierarchy helps you know which exceptions can be caught and how to handle them appropriately. When an exception occurs, Python provides a traceback message, which is a detailed error report that helps you identify where the error happened in your code. Here we see that when we try to divide 10 by 0, Python raises a zero division error and provides a traceback to help you pinpoint the exact location of the error. Now it's your turn. For this exercise, write a program that prompts the user to enter a number. Your program should handle invalid input such as value error when the input is not a number. It should also handle zero division error when the user tries to divide by 0. Additionally, raise a custom exception if the input is 0, indicating that 0 is not allowed. To wrap up, remember that exception handling is crucial in ensuring your program runs smoothly even when errors occur. By using try, accept, and finally blocks, we can catch and handle errors efficiently. Raising custom exceptions gives you even more control over how errors are managed. Lastly, always use Python's helpful tracebacks for debugging. Happy coding! Welcome to day 14 of our course. Today we are working on a mini project where we will create a to-do list app using lists and dictionaries in Python. By the end of this session, you will have built a functional command line application to manage daily tasks. In this mini project, our objective is to build a simple to-do list app. This app will allow users to manage their daily tasks by adding, viewing, editing, and deleting them. We will use Python's lists and dictionaries to store and manipulate the data. Let's take a closer look at the core features of our app. Our tasks will be stored in a list with each task represented as a dictionary. Each dictionary contains key information such as the task's description, status, due date, and priority level. Here's an example of how the data will be structured. Each task will have these four important attributes. The core features of our app include adding a new task, viewing existing tasks, and deleting tasks. The user will be able to enter task details, including the description, due date, and priority level. Once added, the user can view all tasks and even delete them by specifying the task number. In addition to adding and deleting tasks, the app will allow users to edit task details and mark tasks as completed. This functionality makes the app interactive as users can manage their tasks effectively, ensuring they stay on top of their priorities. Let's dive into the code structure. First, we will focus on the function for adding tasks. When the user enters task details, our addTask function will append a dictionary containing the task information to the tasks list. This ensures that the task is stored for future reference. Now let's look at the functions for viewing and editing tasks. The viewTask function will display all the tasks in the list, showing their description, status, due date, and priority. For editing tasks, the editTask function will allow users to modify the task details as needed. The app runs inside a while true loop, providing users with a menu of options to interact with the app. They can add a new task, viewing existing tasks, delete tasks, edit them, or exit the program. This loop ensures continuous interaction with the user until they choose to exit. Once we have the basic app running, there are several optional enhancements we can add. For example, we can implement file handling to save and load tasks, allowing the app to persist even after it's closed. We could also add task sorting or even advanced features like searching for tasks or setting task deadlines. By building this app, you will have practiced working with Python's lists and dictionaries, which are essential data structures for many applications. You have also gained experience in building a command line app and implementing core features like adding, viewing, and editing data. In the next step, you can enhance the app or apply these skills to other Python projects. Welcome to day 15. Introduction to Object-Oriented Programming or OOP in Python. In this lesson, we will explore the fundamental concepts of OOP, including classes, objects, and key features such as attributes, methods, and more. Let's dive in. Object-Oriented Programming or OOP is a programming paradigm that organizes code around objects, which represent real-world entities. These objects contain both data and methods that describe their behavior. OOP offers several advantages: modularity, reusability, scalability. Modularity meaning you can divide your code into smaller, manageable parts. Reusability allowing you to reuse classes and methods in different projects. Scalability, which makes it easier to handle complex and growing code bases. A real-world analogy. Think of a car as an object. It has attributes such as color and model, and methods such as start and stop, which allow it to perform actions. In OOP, classes are blueprints for creating objects. They define the attributes and methods an object will have. You can think of a class as a template for an object. To create an object, you instantiate it from the class. Let's take a look at a simple example in Python. Here we have a car class, but it does not contain any functionality yet. We can create an object of this class by calling car. Once the object is created, we can interact with it and assign values to its attributes or call its methods. Every object created from a class can hold data. These are called attributes. Attributes are variables that belong to an object and hold its data. In our car example, we have two attributes, brand and color. These attributes are defined inside the class and we assign values to them when creating an object. Methods define the behavior of an object. These are functions defined inside a class that can manipulate or return data from the object's attributes. For example, we might have a drive method that prints out a message saying the car is driving. Let's combine everything into a complete example. Here we define the class car with two attributes, brand and color. The __init __ method allows us to set these attributes when we create an object. We also define a drive method which prints out the car's brand and tells us that it's driving. When we create an object, we can call the drive method to see this behavior in action. Now it's time to practice what we have learned. Here are some exercises to help reinforce the concepts of OOP. Create a simple class called person with attributes name and age. Add a greet method that introduces the person. Build a class student with attributes like name and marks. Add a method called display to show the student's details. Define a class book with a default author attribute. As a challenge, create a rectangle class with methods to calculate the area and perimeter. Give them a try and see how well you can apply these concepts. To wrap up, today we explored the basics of object-oriented programming in Python. Here's a quick recap. Classes are blueprints for creating objects. Objects hold data or attributes and perform actions or methods. We also covered the importance of attributes and methods in defining the behavior and data of objects. OOP helps make your code more modular, reusable, and scalable. Keep practicing these concepts and we will and you will soon be able to build more complex systems with Python. Welcome to this lesson on encapsulation in object-oriented programming, or OOP. In this session, we will explore the concept of encapsulation, including public and private members, and how they help in managing the internal state of objects. Encapsulation is one of the fundamental principles of OOP. It involves bundling both data, also known as attributes, and methods, which are functions that operate on the data, into a single unit or class. This means that the internal details of an object are hidden from the outside world. Encapsulation also allows controlled access to these details through public methods, which leads to more secure and manageable code. In a class, we define two types of members, public and private. Public members are accessible from both inside and outside the class, meaning they can be freely modified. On the other hand, private members are intended to be accessed only within the class itself. By making certain members private, we protect the integrity of the data and prevent accidental modifications. Let's look at a code example. Here we have a student class. The name attribute is public, so it can be accessed directly. However, the __ grade attribute is private. To access and modify the grade, we use public methods like getGrade and setGrade. This allows us to add validation, ensuring that the grade stays within a valid range. Next, let's discuss the init method, which is the constructor in Python. This method is automatically called when a new object is created from the class. It initializes the object's attributes with values provided during creation. In the car class, for example, the init method takes two parameters, brand and model, and assigns them to the object's attributes. Here's the code example for the car class. The init method assigns values to the brand and model attributes, and the display information method prints out these values. Whenever a car object is created, the init method ensures that the object is initialized with the correct information. Now let's move on to a practical exercise. We are going to create a person class. This class will have private attributes like __age and __ address. We will also include public methods for getting and setting these private attributes. This demonstrates how encapsulation helps in controlling the access and modification of the object's data. Here is the code for the Python class. The constructor init initializes the name, age, and address attributes. The getAge method allows access to the private __ age attribute, while the setAge method ensures that age can only be updated with a valid value. Similarly, you can add methods to handle the address and any other private attributes. To wrap up this lesson, here are a few questions for you to check your understanding of encapsulation. First, what is the purpose of init method in Python? Second, how do you make an attribute private? And finally, why are getter and setter methods important in encapsulation? Take some time to reflect on these points before moving on to the next lesson. That concludes our overview of encapsulation in object-oriented programming. By using private and public members along with methods like underscore underscore init underscore underscore and getter and setter functions, we can better manage code integrity and enhance the security of our classes. Thanks for watching and happy coding. Welcome to day 17 of our object-oriented programming course. Today we will discuss an essential concept, inheritance. Inheritance is the cornerstone of OOP that enables us to reuse code efficiently and organize it logically. This session will cover its definition, implementation, various types, and practical examples. Let's get started. Inheritance is a mechanism where one class called a derived class inherits properties and behaviors from another class called a base class. It allows us to promote code reusability and create a logical class hierarchy. Key terms to remember are base class, the parent class providing attributes and methods. Derived class, the child class inheriting from the base class. For example, imagine a vehicle as the base class and its derived class could be car and bike. This allows shared properties like speed or fuel capacity to be defined once in the base class and reused by the derived classes. Inheritance is implemented using base and derived classes. In Python, the syntax is straightforward. We have base class methods and attributes and inherited and new methods or attributes. Both Python and C++ let you reuse functionality while enabling extensions in derived classes. Let's look at a simple example. Here's a Python class named vehicle which serves as a base class. The base class defines a constructor to initialize the brand attribute and a method drive that all vehicles can use. This is the foundation of our inheritance example. Now let's derive a class from vehicle. Here the car class inherits from vehicle but overrides the drive method to specify behavior for cars. The derived class builds upon the base class and adds its own unique features. Inheritance also allows accessing parent class members. For example, in the example, dog is inherited from animal, and we are using the speak method from animal using the super keyword. Using super, the derived class can invoke methods or constructors from the base class. Similarly, in C++, the base class : syntax is used for explicit calls to base class methods. Method overriding occurs when a derived class redefines a method from its base class. This allows derived classes to provide specific implementations like calculating the area of a rectangle. Overriding is vital for tailoring the behavior of inherited methods to suit specific needs. There are 5 primary types of inheritance. Single inheritance, a single base class and a single derived class. Multi-level inheritance. Inheritance occurs in a chain-like manner. Multiple inheritance. A single derived class inherits from multiple base classes. Hierarchical inheritance. Multiple derived classes inherit from a single base class. Hybrid inheritance. A combination of the both types. These types help structure complex systems effectively. Protected members strike a balance between private and public access. In Python, these are prefixed with an underscore such as underscore protected attribute. In C++, they use the protected keyword. Here is an example. Protected members ensure controlled access within the class hierarchy while keeping them hidden from external classes. Let's reinforce our understanding with some exercises. Create a person class and derive employee and student classes with unique attributes like salary and grades. Implement a class hierarchy for shapes such as shape, circle, and rectangle, each calculating its area. Create a base class library to manage books and a derived class public library to track issued books. For a challenge, design a vehicle class and derive car and truck, each implementing a custom fuel efficiency method. These exercises will give you hands-on experience with inheritance. By the end of this session, you should be able to explain the concept and benefits of inheritance. Implement various types of inheritance such as single and multi-level inheritance. Use super and constructors effectively in inheritance scenarios. Override base class methods for customized behavior. In our next session, we will discuss polymorphism, focusing on method overloading and overriding. Thank you for participating. Welcome to today's lesson on polymorphism in object-oriented programming, where we will explore method overloading and method overriding. And in this session, we will dive into these key concepts along with some practical Python code examples. Polymorphism is one of the core principles of object-oriented programming. It allows methods in different classes to be called through the same interface, making your code more flexible and reusable. There are two main types of polymorphism. Compile-time polymorphism, also known as method overloading, runtime polymorphism, also known as method overriding. Let's look at each of these concepts in more detail. Method overloading allows us to define multiple methods with the same name but with different parameters. This is useful when we need to perform the same operation in different ways based on the input. For example, you could have a method to add two numbers, another to add three numbers, or even a method to concatenate strings. While Python does not support traditional overloading, it allows us to achieve similar behavior by using default or variable length arguments. Here's an example of how we can implement method overloading in Python. In the calculator class, the add method can take two parameters by default, but we can also pass a third optional parameter using a default value. This way, we can call the method with two or three numbers. Notice that in this case, Python handles the method overloading using the default argument values, allowing us to use the same method with varying numbers of arguments. Method overriding is a technique where a child class provides a specific implementation of a method that was already defined in its parent class. This allows us to modify or customize the behavior in the derived class that was already defined in its parent class. This allows us to modify or customize the behavior in the derived class while maintaining the same method signature. In the example we see here, the animal class has a speak method, but the dog class overrides this method to provide a more specific implementation. This is a classic case of runtime polymorphism. Polymorphism can also be used in functions that accept objects of different types. Here's an example with the animal sound function. This function accepts an object of any class that has a speak method, whether it's a cat, bird, or any other class with a speak method. By calling animal sound, we can pass in different objects, and the correct method is called depending on the object type, demonstrating polymorphism in action. Operator overloading allows us to redefine how operators work for custom objects. For instance, we can overload the plus operator to add two point objects together. In the example, we have defined the underscore underscore add underscore underscore method to handle the addition of 2 point objects. When we use the plus operator, Python calls this method and returns a new point object with the sum of the coordinates. Now it's time for some hands-on practice. Here are a few exercises for you to work on. Write a program that demonstrates method overloading using variable length arguments. Implement a base class shape with an area method and derive classes rectangle and circle. Override the area method in both derived classes to calculate the areas for these shapes. Create a class employee that supports adding the salaries of two employees using operator overloading. These exercises will help you better understand how polymorphism works and how to apply it in your own projects. Polymorphism is a fundamental concept in object-oriented programming that provides flexibility and reusability. We have covered method overloading, method overriding, and operator overloading along with Python examples. Practice these concepts through the exercises and you will be on your way to mastering polymorphism in OOP. Hello everyone and welcome to day 19 of our object-oriented programming course. Today we will be diving into abstraction in OOP in Python. Let's explore what abstraction is, why it's important, and how we can implement it in Python. First, let's define abstraction. Abstraction is the concept of hiding the complex implementation details of a system and exposing only the essential features. For example, when you use a smartphone, you interact with apps and features, but you don't need to understand how the hardware or software works internally. This simplifies the user experience and focuses only on what's necessary. Abstraction is incredibly important in software development. It simplifies complex systems by focusing only on relevant details. It also promotes modularity and reusability, allowing you to update one part of the system without affecting others. Additionally, abstraction enhances security by hiding sensitive implementation details, making your code more secure and maintainable. Now let's talk about abstract classes. An abstract class is a blueprint for other classes. It cannot be instantiated directly. Instead, it contains abstract methods that are declared but not implemented. These methods must be implemented by any subclass that inherits from the abstract class. However, an abstract class can also have concrete methods which are fully implemented. In Python, we use the ABC module to define abstract classes. The ABC class is the base for all abstract classes, and we use the @abstract method decorator to mark methods as abstract. This ensures that any subclass will provide its own implementation of these methods. An abstract method is a method declared in an abstract class but without an implementation. The purpose of abstract methods is to define a contract that any subclass must follow. This ensures that all subclasses provide their own specific behavior for these methods. Let's compare abstract classes with interfaces. In some programming languages, an interface is a strict contract that only allows abstract methods, while Python does not have a formal interface type. Abstract classes can serve the same purpose by defining only abstract methods. The key difference is that abstract classes can have both abstract and concrete methods, while interfaces typically only define methods to be implemented. So, what are the benefits of abstraction? First, it allows for code reusability. Abstract classes provide a common structure, so subclasses can reuse the logic. Abstraction also improves security as it hides implementation details from the user. Finally, it makes your code easier to maintain and extend, as changes in one part of the system do not affect others. Now let's put what we have learned into practice. For today's task, we will create an abstract class called vehicle. This class will have abstract methods like start engine and stop engine. We will then create subclasses such as car and bike and implement these methods in the respective subclasses. Here's a mini project idea, a library management system. We will create an abstract class called library item with methods like checkout and return item. Then we will create subclasses for specific items like book, DVD, and journal. This will help you understand how abstraction can be used to create a structured and scalable system. Let's quickly recap what we have learned. Abstraction helps us hide unnecessary details and focus on essential features. Abstract classes define a common interface for subclasses, ensuring consistency. Finally, abstraction promotes modularity, reusability, and security in our code. That's the end of our lesson on abstraction. Does anyone have any question or need further clarification on any points? Feel free to ask. Welcome to day 20 of our Python course. Today we will dive into modules and packages in Python. We will start by understanding what modules are, how to work with standard libraries, how to create custom modules, and we will finish by exploring packages. We will also walk through practical examples to help reinforce these concepts. Let's begin with an introduction to modules. A module is simply a file containing Python code that can define functions, classes, and variables. Using modules helps us organize our code, making it reusable and more maintainable. This allows us to break our code into smaller, manageable pieces, improving readability and reducing complexity. Python comes with many built-in modules that we can use directly in our code. For example, the math module provides a wide range of mathematical functions. To use it, we can simply import it using the import statement. For instance, using import math, we can call the math.sqrt function to compute square roots. Alternatively, if we only need specific functions, we can import them individually, like this. From math, import sqrt, pi. Python's standard library includes a variety of useful modules. The OS module allows us to interact with the operating system. SYS helps us manage system-specific parameters. Datetime handles date and time, and random generates random numbers. Here's an example of how you can use the OS module to get the current working directory. Import OS followed by print os.get cwd. Now that we have seen built-in modules, let's look at how to create custom modules. To create a module, simply save your Python code in a .py file. For example, let's create a file called mymodule.py with a function greet name. Then to use this module in another script, we mymodule.greet the name. When you create a module, sometimes you may want to run certain code only when the module is executed directly, not when it's imported elsewhere. This is where if underscore underscore name underscore underscore equals to underscore underscore main underscore underscore comes into play. Code inside this block runs only when the script is run directly, not when it's imported as a module. Next, let's explore packages. A package is a directory that contains multiple Python modules along with an underscore underscore init underscore underscore .py file, which signifies that the directory should be treated as a package. Packages allow us to group related modules together. For example, imagine a package called myPackage containing module1.py and module2.py. To use a module from a package, we can use the from keyword. For example, to import module1 from myPackage, we write from myPackage import module1. Then we can use the functions or classes from module1 in our code, such as module1.sum function. Let's take a practical example, creating a banking system package. Imagine a directory called banking system containing two modules, account.py and transactions.py. The account.py module defines an account class, while the transactions.py module contains functions to deposit and withdraw money from an account. In account.py, we define an account class with methods to display account details. In transactions.py, we define functions like deposit and withdraw to modify the balance. You can then import and use these modules in a separate script, providing a simple yet powerful way to manage related functionalities. When working with modules and packages, there are a few best practices to keep in mind. First, always choose descriptive names for your modules and packages to make your code easier to understand. Organize related modules into packages to ensure scalability and avoid circular imports where modules depend on each other in a loop. Now it's time for a mini project exercise. Your task is to create a package called math operations with modules for basic operations like addition, subtraction, multiplication, and division. Test your package by importing and using the modules in a separate script. This will give you hands-on experience in structuring and working with packages. Welcome to day 21 of our Python programming journey. In today's lesson, we are going to apply object-oriented programming principles like encapsulation, inheritance, and polymorphism to build a basic bank account system. This project will give you practical experience in coding and problem solving. Let's take a look at a project overview. Our goal is to create a bank system with classes and derived classes. The system will allow users to check their balance, deposit money, withdraw money, and manage different account types such as savings and current accounts. Now let's discuss the core of our system, the account class. We will need attributes such as the account number, a unique identifier for each account, the account holder which stores the account holder names, and the balance which keeps track of the current balance. The class will have methods like deposit which adds money to the balance, withdraw which allows users to take money out, and check balance which display the current balance. We will also create two derived classes from the account class, savings account and current account. For the savings account, we will add a interest rate attribute, and the method add interest will add interest to the balance. For the current account, the additional attribute is an overdraft limit which lets users withdraw more than their balance up to a certain limit. We will also override the withdraw method to allow withdrawals within this overdraft limit. To tie everything together, we develop a bank system that can manage multiple accounts, perform operations like searching for accounts by account number, depositing or withdrawing money, and viewing balances. Add interest to savings accounts and view all accounts in the system. To make it user-friendly, we will create a menu-driven interface. Here are the options. Create an account, either savings or current. Deposit money, withdraw money, view balance, add interest for savings accounts, view all accounts, exit the system. Next, let's look at the code structure. We will break the project into modules. Account.py. This module will contain the account, savings account, and current account classes. Banksystem.py. This is the main program where we manage the accounts and provide the user interface. Here's an example of the output you might see when running the system. It's a simple menu where the user is prompted to choose an action like creating an account, depositing money, or checking the balance. You can imagine how this interface will guide users through the system's operations. For those looking to go the extra mile, here are some additional challenges you can try. Exception handling. Handle invalid inputs or situations like insufficient balance, data persistence. Save account data to a file and load it when the system restarts. Account closure/transfer. Add features to close accounts or transfer funds between them. By the end of this mini project, you will have a functional bank account system that demonstrates key object-oriented programming concepts. This is a great opportunity to put your coding skills into practice while building a useful application. Welcome to this presentation on file handling in Python. In this session, we will explore how to read and write files and work with different file types such as text files, CSV files, and JSON files. To begin working with files in Python, we need to open them first. This is done using the open function. The syntax is simple. File equals to open file path, mode. The mode specifies how the file will be opened. For instance, R opens the file in read mode, W opens the file in write mode, and A opens it in append mode. There are also binary modes like RB and WB for reading and writing binary files respectively. Once a file is opened, we can read its contents. Python offers three primary methods to read a file. Read, which reads the entire file, readline, which reads one line at a time, and readlines, which reads all lines into a list. For example, to read the whole file, we use file.read. Don't forget to close the file using file.close after you are done. When it comes to writing data to a file, you can use the write method, which writes a string to a file, overwriting the existing content. Alternatively, the writelines method allows you to write a list of strings to the file. In both cases, if the file does not exist, it will be created automatically. Be cautious as the write method will override any existing content in the file. Python supports a variety of file formats. The most common are text files, which store basic data such as letters or numbers. We also have CSV files, which store tabular data in a plain text format, and JSON files, which are lightweight and often used for data interchange, especially in web applications. CSV files store tabular data where each value is separated by a comma. To read and write CSV files in Python, we use the CSV module. The csv.reader method allows us to read the contents, and csv.writer helps us write data to a CSV file. In this example, we are using the csv.reader method to print each row of data from the CSV file. JSON files are widely used for data interchange. To work with JSON files in Python, we use the JSON module. The JSON.load method is used to read data from a JSON file, while JSON.dump is used to write back data to a JSON file. This is particularly useful when working with APIs or configuration files. File operations can fail for several reasons, such as a missing file or lack of permissions. To handle such errors, we use Python's try except block. This ensures that the program does not crash when an error occurs. For instance, if the file does not exist, a file not found error will be caught, and you can provide a custom message. Now that we have a good understanding of file handling, it's time to practice. Your task is to write a Python script that reads a CSV file, processes its content, and writes it to a new text file. Make sure to indicate error handling for potential issues, such as the file not being found or the format being incorrect. This exercise will help solidify your knowledge of file operations. Welcome to day 23 of our Advanced Python Concepts series. Today we will be exploring lambda functions in Python. I am excited to walk you through this powerful feature of Python. Let's begin by understanding what lambda functions are. Lambda functions, also known as anonymous functions, are small one-line functions defined using the lambda keyword. The syntax is simple. Lambda arguments expression. Let's look at an example. Here we define a lambda function called add. It takes two arguments a and b and returns their sum. When we call add 3, 5, it outputs 8. Lambda functions are commonly used for simple operations that don't require a full function definition. Lambda functions can also be passed as arguments to higher order functions, such as map, filter, and reduce. For example, we have a list of numbers 1, 2, 3, 4, and 5. We use map with a lambda function to square each number. The result is a new list 1, 4, 9, 16, and 25. Speaking of map, this function applies a given function to each item in an iterable. In this example, we use map with a lambda to double the numbers in our list. The result is 2, 4, 6, 8, and 10. The map function is ideal when you want to apply a transformation to every element in a collection. Another useful function is filter. The filter function filters out elements that don't meet a condition. For example, using a lambda, we can filter out even numbers from a list containing the elements 1, 2, 3, 4, 5, and 6. The result is 2, 4, and 6. This is helpful when you only want elements that specify a specific condition. Next, we have the reduce function from the functools module. It applies a function cumulatively to the elements of an iterable and reduces the iterable to a single value. Lambda functions are often used in practical situations such as sorting and filtering data. For instance, let's say we have a list of tuples 1, apple, 3, banana, 2, cherry. We can sort this list by the fruit name using a lambda function. The result is 1, apple, 3, banana, 2, cherry. Lambda functions make such operations concise and effective. Now let's talk about best practices. Use lambda functions when the operation is simple and you need it only once. They are perfect for short functions passed as arguments. However, avoid using them for complex operations. If your function is too long or complicated, it's better to use a regular function defined with def for better readability. Now it's time for a hands-on exercise. In exercise 1, take a list of integers and use map with a lambda to square each element, add 10 to each element, filter out elements that are less than 20. In exercise 2, use filter and a lambda function to remove vowels from a string. To summarize, lambda functions are concise, anonymous functions that are defined using the lambda keyword. They are especially useful in functional programming tasks like map, filter, and reduce. Lambda functions are best suited for simple operations or when you need a quick one-time function. Practice using them to write cleaner, more efficient code. Welcome to day 24 of our Advanced Python Concepts series. Today we will be diving into decorators, a powerful feature in Python that allows you to modify the behavior of functions without changing their actual code. Let's get started. First, let's explore what decorators are. A decorator is a special type of function that allows us to add extra functionality to other functions. In simpler terms, it wraps a function and modifies its behavior without altering its core implementation. Decorators are widely used in Python for tasks such as logging, memoization, and even access control. Now let's look at the syntax of decorators. A decorator is itself a function that takes another function as an argument. Inside this function, we define another function, often called the wrapper function, which is the one that will call the original function. Finally, the decorator returns this wrapper function. Here we have a simple example where we decorate the display function. The decorator underscore function line applies the decorator to the display function, adding functionality before the original code is executed. So how exactly do decorators work? When a function is decorated, the original function is passed to the decorator. The decorator then wraps this function inside another function that can add extra behavior. This wrapper function is the one that's actually executed when you call the decorated function. The decorator essentially intercepts the function call, performs some actions, and then either proceeds with or modifies the function's output. Next, let's see how to create custom decorators. Here's a basic example. The simple underscore decorator function takes another function as input and wraps it with additional behavior. Before calling the original function, it prints a message, and after calling the function executes, after the function executes, it prints another message. The output of this decorator is before calling function followed by the function's output and then after calling function. This is the power of decorators. You can add custom behavior around any function. Decorators can also accept arguments. This requires an additional layer of nesting because the decorator itself now needs to accept parameters. In this example, we define a decorator underscore with underscore args that takes a message as an argument and passes it to the wrapper function, which then prints the message before calling the original function. This gives us more flexibility and makes the decorator more powerful. Decorators have many practical use cases. For instance, they can be used for logging, where you log every time a function is called. They can also help with authorization, ensuring that users have the proper access rights before allowing function execution. Another common use is memoization, which caches the results of expensive function calls. And of course, timing functions. Decorators can help you measure how long a function takes to execute. Python comes with several built-in decorators that make our lives easier. The @static method decorator is used to define a static method in a class. The @class method decorator defines a class method which operates on the class itself rather than instances. Lastly, @property is used to define methods that act like attributes, providing a neat way to access computed values. Now let's try a practice exercise, a time decorator. This decorator measures the execution time of a function. We use the time module to record the start and end times, and the decorator prints the time it took for the function to execute. Here we apply the timer decorator to a simple function, slow function, which pauses for 2 seconds before printing a message. This shows you how to create a decorator for measuring performance. To wrap up, decorators are an essential feature in Python that allows you to modify or enhance functions without changing their original code. From logging and memoization to performance tracking, decorators are widely used in Python applications. I encourage you to practice creating your own decorators. Understanding decorators deeply will significantly improve your Python coding skills. Welcome to day 25 of our Python course, where we will dive into generators in Python. Generators are a powerful tool for efficient iteration and lazy evaluation. Let's explore how they work and how you can use them in your code. First, let's define what a generator is. A generator is a special type of iterator in Python. Unlike regular functions that return values all at once, a generator yields one value at a time. Instead of using the return keyword, it uses the yield keyword to return values. This allows the function to pause and resume where it left off, making it memory efficient. Here's a simple example. We have a function called countUp2 which generates numbers from 1 up to a specified limit. Notice that we use the yield keyword inside the while loop. Every time we call next on the generator, it yields the next number. This process continues until the generator is exhausted. So, why use generators? The main advantage is memory efficiency. Generators don't store the entire sequence in memory. They yield one value at a time. This is especially useful for large datasets. Additionally, generators use lazy evaluation, which means values are computed only when requested, leading to faster performance in many cases. Let's compare a list-based approach to a generator-based approach. In the list-based example, we return a list of squared numbers all at once, which can be memory intensive. In contrast, with the generator, we yield each squared numbers one by one, making it more memory efficient, especially for large values of n. Generators work seamlessly with loops. You can iterate through a generator using a for loop, and it will automatically call next on each iteration. This allows you to process items one by one without needing to load everything into memory upfront. Generator expressions are similar to list comprehensions, but they use parentheses instead of square brackets. This makes them more memory efficient since they return a generator instead of a full list. In this example, we are squaring numbers, but we are doing it in a way that does not require storing all the results in memory at once. Generators are also useful for processing large files. In this example, we define a generator that reads a file line by line. The generator yields on one line at a time, so you don't have to load the entire file into memory, making it ideal for processing large files efficiently. Generators can even be used for creating infinite sequences. Here, we define a Fibonacci generator. Instead of calculating the entire sequence, we use yield to generate each Fibonacci number on demand. This allows us to work with infinite sequences, one number at a time. Generators can also be combined with functions like map, filter, and reduce. These functions allow you to apply transformations or filters on the values yielded by a generator. For example, we can square the numbers, filter for even results, and then accumulate the sum of those even numbers, all using generators. To sum up, generators are a powerful tool for efficient iteration and memory management. They provide benefits like lazy evaluation, which computes values only when needed, and they are ideal for working with large datasets, infinite sequence, infinite sequences, and real-time data processing. Understanding generators can help you write more efficient and scalable Python code. Hello and welcome to this presentation on iterators in Python. In this session, we will explore the concept of iterators, how they work, and how you can create custom iterators for your Python programs. Let's dive in. Let's start with an overview of iterators. An iterator is an object that allows you to traverse through all the elements in a collection, such as a list or a tuple. The key to an iterator is that it uses two methods underscore iter underscore to initialize the iterator and underscore next underscore to retrieve the next item in the sequence. Why should you use iterators? Well, they are great for efficient memory usage and simplify the process of iterating through large or even infinite datasets. Now let's look at the two main methods of an iterator. First, the iter method. This method initializes the iterator and returns the iterator object itself. It's required to make an object iterable. Next, we have the next method. This method returns the next item in the sequence. When there are no more items to return, it raises a stop iteration exception, signaling that the end of the iteration. Now let's see how can you create a custom iterator. Consider the following example where you can create an iterator that behaves like Python's built-in range function. In this example, we define the init method to initialize the start and end values, iter to start the iteration, and next to increment and return the next value. As you can see, custom iterators allow you to define your own sequence logic, making Python even more powerful for various use cases. Python provides built-in iterables like lists, tuples, strings, and dictionaries. You can easily convert these into iterators using the iter function. Once an iterable is converted into an iterator, you can use the next function to retrieve items one by one. Here's a simple example with a list. By calling iter on a list, you get an iterator, and using next, you can access the elements sequentially. One of the most common ways to use iterators is with a for loop. The for loop automatically handles the iteration process by calling iter and next behind the scenes. With this, you can loop through all the elements in a collection without manually managing the iteration. This makes your code cleaner and more readable. An important concept when working with iterators is the stop iteration exception. This exception is raised when there are no more items left to return in the iterator. You can handle this exception in your code to gracefully handle the end of the iteration. For example, you might use a try block to catch the exception and output a message when the iteration ends. Now let's look at some exercises to practice what we have learned. First, try creating a custom iterator for generating the Fibonacci sequence. Then explore how you can create an infinite iterator that generates numbers indefinitely. Another exercise is to build an iterator that reads a file line by line. Finally, try using zip to combine multiple iterators into a single iterator. To summarize, iterators are a powerful feature in Python that provide an efficient way to traverse through data. We have seen how iterators work, how to create custom iterators, and how to use built-in iterables with for loops. Understanding iterators can help you write cleaner, more memory more memory efficient code, especially when dealing with large datasets. Thank you for joining this session, and I hope you now feel more confident working with iterators in Python. Welcome to day 27, Regular Expressions in Python. Today we will dive into the world of regex, learning how it helps us search, match, and manipulate strings. We will also explore Python's re module, which makes working with regex easy and efficient. Let's start by understanding what regular expressions or regex actually are. Regex is a sequence of characters that forms a search pattern. It's used to search for specific patterns within strings, making it a powerful tool for text processing. For example, the below example matches a social security number. Regular expressions are built using basic components. Literals are characters that match exactly. For example, A matches the character A. On the other hand, meta characters are symbols that have special meanings. For example, double backslash D matches a digit, 2 backslash W matches a word character, and now let's look at quantifiers and character classes. Quantifiers define how many times an element can appear. For example, asterisk means 0 or more occurrences, and nm means between n and m occurrences. Character classes allow us to specify a set of characters to match, such as ABC, which matches either A, B, or C. To use regex in Python, we import the re module. There are several useful functions in re, such as match, which checks if the pattern matches at the beginning of a string, search, which finds the first match anywhere in the string, and sub, which allows us to replace patterns within strings. Here are examples of how match and search work. Re.match looks for pattern only at the start of the string, whereas re.search searches the entire string for the first match. For example, re.match r prime a b c prime. Next, let's look at re.findAll and re.sub. Re.findAll returns all occurrences of the pattern, while re.sub replaces the matched pattern with a specified string. Meta characters like the dot are used to match any character except a new line, while anchors like match the beginning and end of a string respectively. One of the powerful features of regex is capturing groups. By using parentheses, we can group parts of the pattern and refer to them later. Back references allows us to match the same text as a previous group. Let's now look at a practical example. Here we are using regex to validate phone numbers in the format given below. The pattern ensures that we match exactly 3 digits, a hyphen followed by another 3 digits, another hyphen, and 4 digits. Here's another practical use case, extracting dates. For example, we can extract dates in the format dd mm yyyy using the pattern below. This allows us to capture the day, month, and year separately. For your mini project, you will create a regex based text parser. The task is to open a text file, use regex to extract information like email addresses, phone numbers, and dates, and then display or store the extracted data. Let's quickly recap. Regex is a powerful tool for searching, matching, and manipulating strings. We covered key functions like read.match, read.search, read.findAll, and read.sub. Now it's time to practice. Try validating phone numbers, extracting dates, and validating URLs using regex. And with that, we have covered the basics of regex. If you have any questions or need clarification, feel free to ask now. I am happy to help. Hello and welcome to day 28 of our Python course. Today we will be working on a practical mini project where we will create a file parsing tool using Python. This tool will help us read, process and extract useful information from files. Let's get started. First, let's understand the objective of the project. The goal is to create a tool that reads a file, processes its content, and extracts useful information based on specific patterns using regular expressions. We will work with file handling and regular expressions, two key concepts in Python that you will need for this task. To begin with, we need to set up our project. We will create a folder for the project and include two main files. Input.txt, this will contain some sample data, file underscore parser.py, the Python script that will handle the file processing logic. For the input file, you can include data like emails, dates, or phone numbers, anything you want to extract. Next, let's look at how we will read and write files. In Python, we can use the open function to read from a file. Here's an example. With open input.txt, r as file, content equals to file.read. This reads the entire content of the file. Once we have processed the data, we can write the results to an output file like this. With open output.txt, write as file, file.write parsed results. This will allow us to capture and save the parsed data. Now let's dive into regular expressions or regex, a powerful tool for matching patterns in text. In our tool, we will use regex to extract specific data such as email addresses. For example, we can use this pattern to match email addresses. By using the re.findAll method, we can extract all email addresses from the file content. Once we have extracted the relevant data using regex, we need to display or save the results. We can loop through the extracted emails and write them to the output file like this. With open output.txt, write as files, file.write extracted emails. Then loop through and write each email to the file. Alternatively, we can print the results directly to the console. Both methods will help us verify the data we have extracted. Here are a few enhancements we can make to this tool to improve its functionality. We can allow the user to input the file and specify which type of data they want to extract, like emails, dates, or phone numbers. We can also add support for multiple file types like CSV or JSON and parse them accordingly. Lastly, we can modularize the code, breaking it down into functions for reading files, applying regex, and writing results. This will make the code more organized and reusable. Here's an example of what our input and output files might look like. If you have an input file with text like below, after running our parsing tool, the output file will list the extracted emails, that is john.doe@example.com, jane.doe@example.net. To wrap up, this mini project has helped us learn how to work with file handling in Python and use regular expressions to extract specific data from text. We also saw how to output the results and make enhancements to improve functionality. This is a great hands-on exercise for reinforcing your Python skills. Welcome to day 29 of our Python journey. Today we are diving into NumPy, an essential library for numerical computing in Python. We will be covering array creation, slicing, and indexing, along with some key operations that make NumPy so powerful. Let's start with an overview of NumPy. NumPy stands for Numerical Python and is the foundational library for numerical computing. It enables you to work with multidimensional arrays and matrices. The best part, NumPy is highly efficient, meaning you can perform mathematical operations on arrays quickly and easily, even with large datasets. This makes it an essential tool for tasks in data analysis and scientific computing. To get started with NumPy, we first need to create arrays. An array is essentially a grid of values. And in NumPy, we can create a one-dimensional array as shown here. Notice how we use the np.array function to create the array. You can also create 2D arrays, which are simply arrays of arrays, like the example shown here with 2 rows and 3 columns. Now let's talk about slicing and indexing. This is a way to access and manipulate specific elements in an array. In our first example, we are accessing the first element of the 1D array. Similarly, in a 2D array, we can access specific rows and columns. With slicing, we can extract a portion of an array, such as elements from index 1 to 3. This flexibility makes NumPy arrays easy to work with no matter the dimensions. When working with multidimensional arrays, slicing becomes even more powerful. For example, we can select multiple rows and a specific column at once, like this today array slicing example. Another cool feature in NumPy is Boolean indexing. Here we filter the array to only show elements greater than 3. This allows us to quickly isolate elements that meet specific conditions. Next, let's explore array operations. One of NumPy's strengths is its ability to perform element-wise operations on arrays. This means you can add, subtract, multiply, and divide all elements in an array with just one line of code. For example, adding 5 to every element in the array or multiplying every element by 2. This makes it easy to perform mathematical operations on large datasets quickly. Another useful feature in NumPy is array reshaping. This allows you to change the dimensions of an array without changing the data inside it. In this example, we reshape a 1D array of 6 elements into a 2D array with 2 rows and 3 columns. We can also flatten multi-dimensional arrays back into 1D arrays using the flatten method. NumPy also offers several functions to make array creation easier. You can create an array of zeros or ones using arrange to create arrays with evenly spaced values, or even generate arrays with linearly spaced numbers using linspace. These functions are helpful when you need arrays of specific shapes or values for computations. Now it's time to practice. I encourage you to try the following exercises. Create a 1D array and access its first and last elements. Reshape a 1D array into a 2D array. Slice a 2D array into to extract specific rows and columns. Perform element-wise operations on an array. Filter an array based on a condition like values greater than 10. These exercises will help solidify your understanding of NumPy. To wrap things up, we have learned that NumPy is a powerful tool for creating and manipulating arrays. We explored how to create arrays, slice and index them, and perform mathematical operations. NumPy is efficient and makes working with large datasets and numerical computations much faster. Now we have the foundation to use NumPy for a variety of tasks from data analysis to machine learning. Welcome to today's session on data manipulation with Pandas. In this lesson, we will explore data frames, perform data cleaning, and dive into basic data manipulation techniques that will help you analyze and manipulate data effectively using Python. Let's begin by understanding data frames. A data frame is a powerful 2D labeled data structure similar to a table or a spreadsheet and is one of the core structures in Pandas. You can create a data frame from a dictionary of lists. For example, a simple dataset of name and age can be turned into a data frame using the pd.dataframe method. Alternatively, we can also load data from external files like CSV files using the pd.readCSV function. Now let's take a look at how we can explore data frames. You can display the first few rows of a data frame using the head method. To get information about the data frame, including the data types and any missing values, use the info method. And for statistical summaries of the numerical columns, the describe function will give you insights into the data, such as the mean, standard deviation, and more. Next, let's dive into data cleaning. It's common to encounter missing data in real-world datasets. You can identify missing data using the isNull method. If you want to fill missing values, the fillNA method is your friend. For example, filling missing ages with the mean value of the age column. If you prefer to remove rows with missing data, the dropNA method can do that as well. Data transformation is also essential in cleaning. Sometimes you need to rename columns to make them more meaningful, which can be done using the rename method. Additionally, you need to change the data types of certain columns, such as converting the age column to a float. You can also add new columns to your data frame. For example, adding a new column that calculates a future value or modifies existing data. With a clean data frame in hand, let's explore how to filter and select data. To select specific columns, you can access them by using the column name like df age. To filter rows, you can use a conditional statement. For example, selecting only rows where the age is greater than 30. You can also use the log function for more complex filtering and conditional assignments like marking people over 30 as senior. Now let's discuss sorting and aggregating data. To sort data, we can use the sort values method. For example, sorting by age in descending order. You can also sort by multiple columns, for example by age and then by name. For aggregating data, we often group data by certain categories. The group by method allows us to group the data and perform operations like calculating the mean age of each group. Let's now put these concepts into action with a practical example. We have a CSV file containing some data. We can load the file into a data frame using pd.readCSV. Once loaded, we check for missing values using the isNull.sum method. We then fill missing values or drop rows with missing data. This is a crucial step before doing any further analysis or transformation. Continuing with the example, we may want to perform data manipulation, such as adding a new column that categorizes people as young or old based on their age. Finally, after cleaning and manipulating the data, we can save the cleaned data frame back to a CSV file using the toCSV method. Once you have mastered basic data manipulation, there are additional topics worth exploring. You can learn how to merge multiple data frames using the merge function. Another useful technique is creating pivot tables to summarize your data. Finally, Pandas also offer robust tools for handling time series data through pd.toDateTime and resample methods. To conclude, today we explored the core functionalities of Pandas for data manipulation. You learned how to create and explore data frames, clean data, and perform common manipulations like filtering, sorting, and aggregation. Remember, the ability to manipulate data effectively is an essential skill for any data analysis or data science task. Keep practicing and soon you will be comfortable using Pandas to work with complex datasets. Welcome to day 31 of our Python for Data Science course. In this section, we will dive into data visualization with Matplotlib, a powerful library used to create static, animated, and interactive visualization. In this session, I will be guiding you. Let's begin by understanding what Matplotlib is. Matplotlib is a Python library that allows us to create various types of visualizations, from simple line plots to more advanced plots like 3D and animated graphs. The key component of Matplotlib is the pyplot module, which provides MATLAB-like functions for plotting. First up, we have the line plot. A line plot is used to display data as a series of points connected by straight lines. This type of plot is particularly useful when we want to visualize trends over time or in continuous data. Here's a simple example. We have values for x and y, and we use the plot function to plot them. Next, we move on to bar plots. Bar plots are excellent for comparing discrete categories. Each bar represents a different category or value. In the fourth example here, we are comparing the sales of 4 categories, represented as bars. Another important plot is the scatter plot. Scatter plots help us show the relationship between two continuous variables. In this example, we plot x and y values as points on the graph. Each point represents a single observation, making scatter plots great for identifying patterns or correlations in data. To make our plots more informative, we can add titles and labels. By adding a title to the plot and labeling the x and y axes, we make the plot much clearer for anyone viewing it. Here's how we do it with the title, X label, and Y label functions. We can further enhance our plots by adding a grid for better readability and legends to explain what each line or data series represents. In this example, we are plotting two lines and adding a grid as well as a legend to identify the lines. Customization does not end with labels and legends. We can also control the colored line styles and markers in our plots. This is useful when we want to distinguish between multiple lines or emphasize certain data points. In this example, we change the line style to dashed and use circular markers. Sometimes we may want to display multiple plots within a single figure. This is where subplots come in handy. Subplots allow us to create a grid of plots so we can compare multiple data visualizations side by side. Here we create a one row, two column subplot to show a line plot and a scatter plot together. Let's look at some more advanced customizations. Histograms are used to display the distribution of data, and pie charts are great for visualizing proportions. In the example, we plot a histogram to show the distribution of data points and a pie chart to visualize the percentage breakdown of categories. Once we have customized our plots, we often want to save them for later use. Matplotlib allows us to save our plots as images. Using the savefig function, we can save our plots in various formats like PNG, JPG, or SVG. Now let's take a look at some mini project ideas. You can practice what you have learned by creating your own visualizations. For example, you could create a line plot to visualize stock market trends, a bar plot to compare sales of different products, or a scatter plot to analyze the relationship between temperature and humidity. To summarize, today we covered the basics of data visualization with Matplotlib. We learned how to create line, bar, and scatter plots and how to customize them with titles, labels, grids, and colors. We also explored advanced customizations like histograms, pie charts, and subplots. As your next step, try creating your own plots and experiment with different datasets. Happy coding! Welcome to day 32 of our course on Python. Today we will be diving into the world of databases with a focus on SQLite. We will learn how to set up and perform CRUD operations using Python's SQLite 3 module. Let's start by understanding what SQLite is. SQLite is a lightweight, serverless, and self-contained SQL database engine. It's designed for small to medium-sized applications and stores data in a single file, making it easy to distribute. Its simplicity makes it perfect for local databases and testing purposes. In Python, SQLite integrates seamlessly through the SQL3 module. To set up SQLite in Python, first we need to import the SQLite 3 module. Then we connect to a database using SQLite3.connect. If the database file does not exist, it will be created automatically. Once connected, we create a cursor object using con.cursor, which allows us to execute SQL commands. Now let's create a table in SQLite. We can use the create table SQL statement. Here's an example of creating a student table with three columns: ID, name, and age. The ID column is primary key, meaning it's unique for each record. If the table does not exist, we can add if not exist to avoid errors. Next, let's look at how to insert data into our SQLite database. To insert a single record, we use the insert into SQL command. We can also insert multiple records at once using execute many. After making changes, don't forget to commit the changes to save them using can.commit. To read data from the database, we use the select query. The select star command retrieves all the rows from a table. If we want to filter data, we can use the where clause. For example, we can query all students older than 21 by using select star from students where age is greater than 21. To update data in the database, we use the update query. For example, if we want to update the age of a student, we use the set keyword followed by the new value. In this case, we are setting the age to 25 for a student named John Doe. As always, remember to commit the changes with can.commit. If you need to delete records from the database, you can use the delete query. Here we are deleting a record where the name is John Doe. After deleting, commit the changes to ensure they are saved to the database. Once you have finished working with the database, it's important to close the connection to free up resources. We do this using the con.close command. Always close the connection after performing operations to ensure everything is properly cleaned up. Let's go over some best practices when using SQLite. First, always use con.commit after making changes to ensure they are saved. Second, use parameterized queries to prevent SQL injection, a common security vulnerability. And finally, consider using with statements to automatically handle the connection, which ensures it gets properly closed even if an error occurs. For your practical exercise, try building a bookstore database. Create tables for books, customers, and orders. Implement CRUD operations for each table, and use real-world examples like book titles, prices, and customer information. To learn more about SQLite and SQL, I encourage you to check out the official SQLite documentation and online SQL tutorials. These resources will deepen your understanding of database management and SQL syntax. That concludes day 32, where we explored SQLite and how to perform basic database operations with Python. Keep practicing these concepts and you will be well on your way to mastering databases. Welcome to today's presentation on web scraping with BeautifulSoup. In this session, we will explore how to extract data from websites using Python, especially with BeautifulSoup library. Let's get started. Web scraping is the process of extracting data from websites for analysis. It's useful for a variety of purposes, such as tracking prices, gathering news, or collecting research data. By automating this process, we can save a lot of time that would otherwise be spent on manual data collection. To perform web scraping, we use two primary libraries, Requests and BeautifulSoup. The Requests library allows us to send HTTP requests to websites, retrieving the HTML content of web pages. BeautifulSoup is a powerful tool that helps us parse this HTML content, making it easy to extract relevant data. Sometimes we also use the LXML library for faster parsing. Before starting, we need to install the necessary libraries. You can do this using pip. Simply type pip install requests BeautifulSoup 4 to install requests and BeautifulSoup. For additional speed, you can install LXML with pip install LXML. Once the libraries are installed, we can send HTTP requests to fetch a web page. For example, we use the requests library to send a GET request to a URL and then access the HTML content using response.txt. This gives us the raw HTML of the page, which can be parsed in with BeautifulSoup. Now let's use BeautifulSoup to parse the HTML content we have retrieved. We create a BeautifulSoup object passing the HTML content and the parsing method html.parser. The prettify method helps format the HTML in a readable structure, making it easier to navigate and extract data. Once we have the parsed HTML, we can find specific elements within it. To find a single element, we use the find method. For example, soup.title will return the title of the web page. To find multiple elements, such as all paragraphs on the page, we use findAll, which returns a list of matching text. BeautifulSoup allows us to extract not just text but also attributes from HTML text. For example, if we want to retrieve the URL from a hyperlink, we can access the href attribute of an A tag. We can also extract the text inside any HTML element using the .text method. Many websites organize data into lists or tables. BeautifulSoup makes it easy to extract this data. For example, we can look through all A tags to extract links from a page. Similarly, we can extract data from tables by finding tr tags for rows and td tags for individual table cells. Web pages often contain nested elements, meaning one tag is inside another. BeautifulSoup makes it simple to access these nested tags by chaining find or findAll methods. For example, you might first find a div tag, then find another div tag inside it, allowing you to navigate complex HTML structures. Once we have extracted data, we need a way to store it. We can use Python lists or dictionaries to collect the information. For more structured storage, we can use the Pandas library to save data into a CSV file, which makes it easy to work with later. Not all web pages are static. Some use JavaScript to dynamically load content. In such cases, the data may not be present in the initial HTML, but instead loaded after the page renders. To handle dynamic content, we can use tools like Selenium or Playwright, which simulate a web browser and can interact with pages that rely on JavaScript. While web scraping is powerful, it's important to follow ethical and legal guidelines. Always check a website's robots.txt file to see if scrapping is allowed. It's also crucial to avoid overloading websites with too many requests in a short period, so consider using delays between requests. Lastly, always respect copyright and terms of service. To put what we have learned into practice, here are a few mini project ideas. First, create a price tracker by scraping product prices from e-commerce websites. Second, build a news aggregator by scraping headlines from multiple news sites. Lastly, scrap job listings from job boards and save the results into a CSV file. In summary, web scraping is a powerful tool for gathering data from websites. With the requests library, we can fetch HTML content, and with BeautifulSoup, we can parse and extract the information we need. Always be mindful of legal and ethical considerations when scraping, and most importantly, practice by working on mini projects to sharpen your skills. Welcome to this session on APIs in Python. Today, we will explore what APIs are and how they enable software applications to communicate with each other. An API, or Application Programming Interface, defines the rules for interacting with a system or service. It allows data exchange over the internet. Common formats used in APIs are JSON, which is lightweight and easy to use, and XML, which is still used but less common today. Next, let's take a look at the HTTP methods used to interact with APIs. The most common methods include GET, used to retrieve data from an API, POST, used to send data to the API, often to create new resources, PUT, used to update an existing resource, DELETE, used to remove a resource from the system. To work with APIs in Python, we use the requests module. It's simple and easy to use for making HTTP requests. You can install it using pip install requests. With this module, you can send various types of requests, handle responses, and work with APIs efficiently. Let's see how to send a GET request. Here's an example where we retrieve data from a public API. We use the request.get method and pass the API's URL. If the request is successful, we get a status code of 200 and can parse the response with .json. This converts the JSON data into a Python dictionary. Now let's look at how to send a POST request. This method is used when we need to send data to an API, such as creating a new resource. Here we pass data as a dictionary using JSON equals to data. If successful, the server will typically respond with a 201 status code and a newly created resource. APIs usually return data in JSON format. In Python, we can easily handle this using the .json method. Once the data is in dictionary form, we can access it like any other Python object. In this example, we access each post title and print it. While working with APIs, it's important to handle errors. If the response data's code isn't 200, we need to check what went wrong. For example, a 404 means the resource was not found, and a 500 indicates an internal server error. Always handle errors to ensure your application runs smoothly. Sometimes we need to pass query parameters in the URL to filter or customize the data returned by the API. We can do this by adding a dictionary of parameters to our request.get method. which will automatically include them in the URL. Let's look at a practical example where we fetch weather data using an API. First, we need to get an API key from a weather service like OpenWeatherMap. Then we use the API key to request weather data for a specific city. The response contains weather details such as temperature, which we can extract and display. When working with APIs, it's essential to follow best practices. First, respect rate limits to avoid overloading the server. For authentication, use API keys or OAuth tokens. Lastly, always handle errors properly by checking the response status code and responding accordingly. To summarize, APIs allow us to exchange data between systems. In Python, we use the request module to make HTTP requests and work with APIs. JSON is the most common data format, and we can handle GET, POST, and other HTTP methods. Don't forget to handle errors and queries and query parameters when needed. For your practice, try fetching data from a public API and dispatching it. Then create a script that sends a POST request and handles the response. This hands-on experience will help reinforce your learning. Welcome to day 35, Practice Mini Project, Web Scraper or Data Analysis Project. Today we will be combining the skills we have learned in web scraping, data manipulation and visualization using Python libraries such as NumPy, Pandas, BeautifulSoup and Matplotlib. On this day, the objective is to reinforce your understanding of data manipulation, web scraping, and working with key Python libraries. You will choose between two mini projects, web scraping or data analysis. Let's dive into these two exciting options. Project 1 is about creating a web scraper. You will be extracting structured data from a website using BeautifulSoup and the requests module. The goal is to clean and process the data, store it in a structured format, and optionally visualize it to gain insights. Let's explore the steps for this project. Here are the steps for creating your web scraper. First, choose a website with structured data such as an e-commerce site or a weather forecast. Scrape the data using the requests library to fetch the web page and BeautifulSoup to parse the HTML content. Identify the HTML tags or classes that hold the relevant information and extract it. Clean and format the data using Pandas and NumPy. Save the cleaned data in a structured format like CSV or Excel. Optionally, you can visualize the data with Matplotlib, for example, by plotting trends in stock prices or weather patterns. Throughout this project, you will gain hands-on experience with web scraping using BeautifulSoup and requests. You will also practice cleaning and manipulating data using Pandas and NumPy. Additionally, you will learn how to store data in CSV or Excel format and visualize it using Matplotlib. Project 2 focuses on data analysis. In this project, you will analyze a dataset using Pandas and NumPy. You will clean and transform the data, perform exploratory data analysis, and visualize your findings. This project is great for anyone who enjoys working with data to uncover insights. Here are the following steps to follow data analysis. Choose a dataset from sources like Kaggle or data.gov. Load the dataset using Pandas and inspect its structure. Clean the data by handling missing values, removing duplicates, and filtering out irrelevant information. Transform the data by converting data types, parsing dates, or creating new columns as needed. Perform exploratory data analysis using descriptive statistics with Pandas and NumPy. Visualize the data using Matplotlib to uncover patterns, trends, and insights. Finally, summarize your findings and write a report detailing the insights you have gained from the data. With this project, you will gain experience in data loading and inspection with Pandas. You will also master data cleaning and transformation techniques. Additionally, you will perform exploratory data analysis using Pandas and NumPy and visualize your findings with Matplotlib. To help you complete the projects, here are some useful resources. BeautifulSoup documentation for web scraping, Pandas documentation for data manipulation, NumPy documentation for numerical computations, Matplotlib documentation for creating plots and visualizations, Kaggle datasets where you can find open datasets to analyze. By the end of this mini project, you will have practical experience in either web scraping or data analysis. You will learn how to clean, transform, and visualize data, and you will create a useful project that you can showcase in your portfolio. Good luck with your project and enjoy the learning process. Welcome to day 36 of our course on object-oriented programming. In today's lesson, we will be diving into unit testing using Python's built-in framework, unittest. Today, we will cover key concepts in testing, including why it's important and how to write effective test cases. Before we begin, let's understand what testing is. Testing ensures that software works as expected. There are several types of testing in software development. Unit testing, which tests individual functions. Integration testing, which focuses on how different components work together. System testing, which tests the entire application. And finally, acceptance testing, which verifies that the software meets business requirements. Testing is crucial for several reasons. It helps identify bugs early in the development process, ensuring that the code behaves as expected. It also helps maintain code quality, especially when refactoring, and ensures the long-term stability and reliability of the software. Unit testing provides numerous benefits. It allows you to catch bugs early before they become big issues. It ensures that individual parts of your code are working as expected, which is key for long-term software quality. Unit tests also make it easier to refactor your code, knowing that any breakages will be immediately flagged. In Python, we use the unit test framework for writing unit tests. The basic structure of a test case is to subclass unit test, test case, and define methods that start with a word test. These methods contain assertions that check whether the code works as expected. Let's look at a simple example. We have a function add a, b that adds the sum of two numbers, that returns the sum of two numbers. We write a test case in a class that subclasses unit test. Test case. The test add method contains assertions like self.assert equal add 1, 2, 3, which checks if the result of add 1, 2 is indeed 3. Unit test provides several built-in assertions to check conditions. Assert equal a, b checks if a equals b. There's also assert not equal a, b to check if two values are not equal. Assert true x and assert false x to check Boolean values, and assert raises to ensure that a certain exception is raised during execution. Writing test cases. When writing test cases, it's important to ensure that they are clear, independent, and focused on one specific aspect of the function. Method names should describe the test purpose clearly, like test addition of two numbers, so anyone reviewing the code can easily understand the test's intent. Here's another example. Consider a function subtract a, b that returns the difference between two numbers. The test subtract method contains several test cases, including subtraction, subtracting positive numbers, negative numbers, and edge cases like subtracting 0 from 0. To run your unit tests, simply use the following commands in your terminal. Python -m unit test module.py. This will execute the tests defined in test module.py and provide you with a report on the success or failure of each test. There are several best practices to keep in mind. One is test-driven development, where you write tests before writing the actual code. Tests should be independent of each other to avoid dependencies. Additionally, mocking is a technique used to simulate parts of the system that are not the focus of the test, ensuring that tests are isolated. Now it's time for some hands-on practice. Your first task is to write test cases for a function that checks if a number is prime. The function should be called isPrimeN. Be sure to test edge cases like 0, 1 and negative numbers, as well as prime and non-prime numbers. For the second task, write test cases for a function reverse string s. This function should reverse the given string. Test cases should cover scenarios like empty strings, single character strings, and multi-character strings. To summarize, today we covered the basics of unit testing, the importance of writing tests, and how to use Python's unit test framework. We also looked at common assertions and best practices. Remember, testing is an ongoing process, and writing effective tests ensures your code is robust and maintainable. Before we conclude, here are some additional resources for you to explore. The official Python unit test documentation is a great place to start, and if you are interested in test-driven development, the book Test-Driven Development by Kent Beck is highly recommended. You can also explore other testing frameworks like PyTest and Nose for more advanced testing techniques. Welcome to day 37, Debugging Techniques in Python. In this session, we will explore essential debugging tools and strategies that will help you identify and resolve issues in your Python code effectively. First, let's understand the types of errors you might encounter in Python. There are three main categories. Syntax errors. These occur when there's an issue with the code structure, like missing parentheses, or incorrect indentation. Runtime errors. These happen during execution, such as trying to divide by 0 or accessing an invalid index. Logic errors. These are tricky because the program runs but produces incorrect results. These errors often require deeper investigation. Effective debugging starts with understanding how to troubleshoot common issues. You can use print statements to track variable values and the flow of your program. Define the problem area by narrowing down the issue to a specific part of the code, commenting out sections if needed. Simplify the code to isolate the error. And finally, read traceable read tracebacks carefully. When an error occurs, Python provides a traceback with information about where the error happened, which helps you locate the issue. Let's dive into using PDB, Python's built-in debugger. You can set breakpoints in your code using the import pdb.setTrace statement. This will pause the program at that point, allowing you to interactively inspect variables and step through the code to track down bugs. When you are using PDB, there are several commands you can use to navigate through your code. N stands for N next, execute the next line within the current function. S step into a function called to debug it. C continue, resume the program until the next breakpoint. P expression, print the value of an expression. Q quit, exit the debugger when you are done. Here's an example of using PDB in a function that divides two numbers. Notice the pdb.traceback call. When the program reaches this point, it will pause and you can inspect the variables a and b and step through the code line by line. Moving beyond the basics, you can also use IDE debuggers for a more visual debugging experience. Popular IDEs like PyCharm and VS Code allow you to set breakpoints, step through your code, and inspect variables with ease. Another valuable tool is logging. Using Python's logging module, you can keep track of program behavior over time, making it easier to identify and debug issues later. Here's an example of how to use the logging module. Instead of using print statements, logging provides a more flexible solution. With logging, you can log messages of different severity levels such as debug, info, warning, error, and critical. Unit testing is another powerful technique for debugging. By writing tests for individual functions, you can catch bugs early, ensuring code works as expected. Unit tests also help isolate errors and they ensure that future changes to the code do not introduce new bugs. Now it's time to practice. Here are 3 exercises to help you refine your debugging skills. Write a division function that handles division by 0 and use PDB to debug the exception. Create a script with a logic error and use PDB to find and fix it. Implement logging in a small banking system program. Introduce an error and debug it using logs and breakpoints. To summarize, debugging is an essential skill for any developer. Use print statements, PDB, and logging to troubleshoot effectively. Leverage advanced tools like IDE debuggers for a more visual experience. And remember, Unit testing is a great way to catch bugs early. By practicing these techniques, you will become a more efficient and confident debugger. Welcome to day 38 of our object-oriented programming course. Today we will be diving into the concept of multithreading, learning about threading, its benefits and best practices. Let's get started. Multithreading allows a program to perform multiple tasks concurrently within a single process. Threads are the smallest unit of execution and share the same memory space, making communication between them more efficient. This approach helps improve CPU usage, especially when performing IO-bound tasks, and is perfect for tasks that can run in parallel without interfering with each other. Let's take a quick look at the differences between threads and processes. Threads are lightweight units of execution within a process, sharing the same memory space. On the other hand, processes are independent programs, each with its own memory space. Threads are generally more efficient than processes because of their ability to share resources quickly, but they come with their own challenges. Python makes multithreading simple with the threading module. This module allows you to create and manage threads in your program. For example, here we define a simple thread that prints numbers from 1 to 5. We create a thread using the thread method, start it with start, and use join to ensure the main thread waits for the new thread to finish before continuing. Synchronization is crucial when multiple threads access shared resources. Without it, you risk data inconsistency. Logs, also known as mutex, help prevent this by ensuring that only one thread can access a resource at a time. In the example here, we use a log to ensure that both threads print numbers safely without interference. Now let's talk about deadlocks. A deadlock happens when two or more threads are waiting for each other to release resources, causing the program to come to a halt. To prevent deadlocks, we should lock resources in a consistent order and use timeouts to avoid threads getting stuck indefinitely. Managing a large number of threads can be inefficient. Instead of creating new threads every time, Python offers thread pooling with the thread pool executor. By defining a pool of threads, you can easily distribute tasks to available threads, improving the efficiency of your program. The example here demonstrates how to use thread pool executor to run tasks concurrently. When working with multithreading, be aware of common issues like the global interpreter log or GIL, which can limit Python's ability to execute CPU-bound tasks in parallel. Another common issue is race conditions, which occur when multiple threads try to access shared data at the same time. The best way to handle this is by using logs or other synchronization mechanisms. To work efficiently with multithreading, keep a few best practices in mind. Minimize shared resources to avoid the need for complex synchronization. Use synchronization mechanisms like locks to prevent data corruption. Optimize with thread pooling to avoid the overhead of creating too many threads. Finally, always profile and test your code to ensure performance is not being compromised. Now let's put what we have learned into practice with a hands-on activity. Your task is to create a multi-threaded program that fetches data from multiple URLs concurrently. Use synchronization with logs to manage shared resources and then optimize your program with thread pool executor to handle a large number of tasks efficiently. Welcome to day 39, Working with Asynchronous Programming. In this session, we will dive into the concepts of asynchronous programming in Python using async, SEO, async, and await. Let's explore how these tools can help us manage concurrent tasks efficiently. To start, let's understand what asynchronous programming is. Asynchronous programming allows multiple tasks to run concurrently without blocking the main program flow. This is particularly useful for IO-bound tasks such as making web requests or reading and writing files, but the program does not need to wait for one task to finish before starting the next. Now, how does Python's async SEO module make this happen? It uses an event loop to manage and schedule asynchronous tasks. By using async and await, Python allows us to write asynchronous code without manually handling threads or processes. Let's see how this works. Here are some core concepts in async SEO that we need to understand. First, coroutines. These are functions defined with the async def syntax. Coroutines can pause their execution using the await keyword and resume once the awaited task is completed. Next, tasks. A task is essentially a coroutine that has been wrapped in a way that allows it to run concurrently with other tasks. Finally, the event loop. The event loop runs in the background and schedules these tasks. It allows one task to execute while another is waiting for something, like IO operation to finish. Let's look at a simple example of how async SEO works. In this example, we have two tasks, task 1 and task 2. Both tasks start running concurrently. Notice how we use await async SEO.sleep to simulate an IO operation. This non-blocking operation allows task 1 to run while task 2 waits for 1 second before finishing. Meanwhile, task 1 continues its execution and completes after 2 seconds. When we use asyncio.gather, both tasks are executed concurrently. This ensures we don't waste time waiting for one task to finish before starting the other. Now let's break down the async and await keywords. The async keyword is used to define a coroutine. It tells Python that the function is asynchronous and will contain await expressions. Inside these coroutines, you can use the await keyword to pause the execution and wait for another asynchronous operation to complete, such as IO or time delay. In this way, async and await allow us to manage concurrency in a very intuitive way. Let's apply this to a practical example, building a simple web scraper. In this code, we use the AIO HTTP library to make non-blocking HTTP requests. Each URL is fetched concurrently using asyncio.gather. By using asynchronous programming, we avoid waiting for each request to finish one by one, making the scraper much more efficient when dealing with multiple URLs. Now let's talk about error handling in asynchronous programs. Just like in regular Python functions, we can use try and catch blocks inside coroutines to catch exceptions. If an error occurs while one task is running, it will be caught by the except block. However, remember that uncaught exceptions will propagate to the event loop and may stop other tasks from executing. Asynchronous programming is not only for web scraping, it's widely used in real-time applications such as chat applications or multiplayer games, where multiple users interact with the system at the same time. Web scraping, where we make multiple non-blocking requests to gather large datasets quickly. IO-bound tasks like downloading files or interacting with databases where asynchronous programming can significantly improve performance by not blocking the main program. To recap, Asyncio helps us manage concurrency in Python by using coroutines and an event loop. Coroutines are defined with async_def and we use await to pause execution until another task completes. Asynchronous programming is ideal for IO-bound tasks where it helps us handle multiple tasks concurrently without blocking. This approach allows us to write more efficient, responsive, and scalable programs, especially when dealing with tasks that involve waiting, such as network operations or file I/O. This concludes our session on asynchronous programming. I hope you now have a clearer understanding of how to use asyncio, async, and await to write concurrent programs in Python. Keep practicing and you will be able to apply these concepts in real-world applications. Welcome to day 40 of our Python course. In this session, we will dive into web development with Flask, a lightweight framework in Python. The objective is to learn how to build a simple web application using Flask. We will cover the basics including routing, template rendering, and handling forms. Let's start with an introduction to Flask. Flask is a microwave framework for Python which is lightweight and easy to use. Unlike Django, which is a full-fledged web framework, Flask gives you more control and flexibility to add only the components you need, making it great for small to medium-sized web applications and APIs. Now let's see how to install Flask and set up a basic project. You can install Flask using pip by typing pip install flask in your terminal. Once installed, we will create a simple project structure. You will have a app.py file for your main code, a templates folder for your HTML files, and a static folder for CSS and JavaScript. To create a basic Flask application, you need to import Flask and render template. The app is initialized with Flask name. The @app.router decorator defines the URL path, and in this case, it's the home page, which renders an index.html template. Finally, we use app.run debug equals to true to start the server, enabling debugging for easier development. Flask uses routing to map URL paths to functions. In this example, we have defined a route for the About page. Additionally, Flask allows dynamic routing. We can pass parameters like username in the URL, and Flask will render the corresponding content like greeting a user with their name. Flask allows you to handle user input via HTML forms. Here's an example of a simple form where the user enters their username. We use the post method to send the data to the server, and in Flask, we access the form data using request.form. Once the form is submitted, we can delete the user by their name. Flask uses Jinja to a powerful templating engine to render dynamic content. In our template, we can pass variables like name from Python to the HTML. For example, when visiting a URL like /greet/John, Flask will render a greeting saying "Hello John" by substituting the placeholder name with the actual value. Static files like images, CSS, and JavaScript can be served from the static folder. In this example, we are linking a CSS file using the URL for function to ensure that Flask properly serves the static file. This allows us to style our web pages with custom CSS. To run the Flask app, we use the command python app.py in the terminal. This starts the Flask development server, and you can access your web application in the browser at http 127.0.0.1:5000. Flask will automatically reload the server when you make changes, which is great for development. For your practice, I suggest building a simple to-do list application using Flask. In this mini project, you will create functionality to add, view, and delete tasks. You will work with forms for user input and dynamically render the tasks using templates, helping reinforce the concepts we have learned so far. As we conclude, here are some advanced topics to explore. Once we are comfortable with Flask basics, you can dive into more complex features like session handling for storing user data, implementing user authentication, and even deploying your Flask application to a production server. These will take your web development skills to the next level. Welcome to today's session on working with Django. In this presentation, we will introduce you to Django, a powerful Python web framework, and guide you through creating a basic web application. Let's start with an overview of Django. Django is a high-level Python web framework that promotes rapid development and clean, pragmatic design. It comes with several key features that make it easy to build powerful web applications, including a built-in admin interface, automatic database migrations, and strong security features such as protection against SQL injection and cross-site scripting. It's also highly scalable and offers reusable components for better code management. Django follows the model view template or MVT architecture. In this pattern, the model is responsible for the data structure, essentially mapping to your database tables. The view contains the logic that dictates how the data is presented, and the template is the actual HTML file that displays the data to users. Django also features URL conf, which maps URLs to views, and a built-in admin interface that helps manage application effortlessly. To set up a Django project, first install Django using pip with the command pip install Django. Once installed, you can create a new project by running Django admin start project my project. This will set up the basic structure for your project, which includes directories for settings, URLs, and applications. After setting up your project, you can run the development server using the command python manage.py run server. This will start a local server on your machine, which you can access by visiting http 127.0.0.1:8000 in your web browser. This allows you to see your Django app in action. Now let's create an app within our Django project. An app is a smaller functional module that you can use across different projects. To create an app, run the command python manage.py start app my app. This will generate the necessary files for your app, including models, views, and URLs. In Django, views define the logic behind rendering data. For example, a simple view might render a template when a user visits a certain URL. Templates are HTML files that contain the structure of your page. For instance, the home.html template might display a welcome message to users. Views and templates work together to create dynamic web pages. URL routing in Django maps URLs to specific views. For instance, you can define a path in the urls.py file like path views.home, which will link the root URL to the home view. This ensures that users are directed to the right view when they access a particular URL. Models in Django represent your data. For example, you might define a post model to store blog posts. Models are created using Django's Object Relational Mapping or ORM, which automatically translates Python code into database queries. Once you create a model, you can apply migrations to update your database structure. One of the most powerful features of Django is its built-in admin interface. By enabling the Django admin in your settings, you can manage your data easily. You can create a super user to access the admin interface by running python manage.py create super user. Once logged in, you can add, edit, and delete data directly from the browser. As a mini project, let's consider building a simple blog application. You will define a post model, create views to display and add posts, and configure URL routing to navigate between pages. Additionally, you will use Django's admin interface to manage the posts you create. To recap, Django simplifies web development by providing a built-in admin interface, security features, and a clean architectural pattern. With its model view template structure, Django enables efficient code organization. I encourage you to dive deeper into Django's forms, authentication, and more advanced features to take your web development skills to the next level. Welcome to day 42 of our course, where we focus on building a mini project to apply everything we have learned so far. In this session, we will dive into creating a small web application using either Flask or Django, two popular web frameworks in Python. Let's get started. Today's objective is to take the concepts we have covered in the previous days and put them into practice. By the end of this session, you will have built your own small web application using Flask or Django. This is a great opportunity to consolidate your knowledge of web frameworks and Python while learning how to deploy a fully functional web app. For your mini project, you have the choice of using either Flask or Django depending on your preference or prior experience. Some project ideas include a to-do list app, a personal blog, or even a simple note-taking app. Your goal is to build and deploy a working web application with basic functionality. Let's start with a Flask approach for those who want to work with Flask. First, you will need to install Flask using the command pip install Flask. The typical project structure includes folders for static files like CSS and images, templates for HTML files, and a Python file, usually called app.py, where we define our routes and logic. Now let's look at creating routes in Flask. A route defines the URL pattern that triggers a specific function in your app. For example, you can have a route for the home page, an about page, and even a route for adding tasks to your to-do list. Flask also uses Jinja templating to dynamically render HTML with data from Python. When handling user input, you will need to create forms. Use the request module in Flask to retrieve form data submitted by the user. You can store this data in a simple list or for persistence, a database like SQLite. Once your app is ready, you can run it locally with the command python app.py. If you want to take it in step further, you can deploy your app on platforms like Heroku or Python Anywhere. For those who prefer Django, the setup begins with installing Django using pip install Django. After installation, you will create your project and app using commands like Django admin, start start project, my Django app, and Python manage.py start app to do. Django follows the model view template architecture, which is more structured compared to Flask. Once your project is set up, you can define your models in Django. Models represent the data structure of your app, and Django automatically creates the necessary database tables for you. After creating models, you will run migrations to apply the changes to your database. Next, you will create views that handle the logic and render templates with data. Django also provides a built-in admin interface which allows you to manage your data easily. It's a great tool for administrators or developers to input and modify data without needing to build additional forms. Once you are ready, deploy your Django app on platforms like Heroku or DigitalOcean to make it accessible online. For the mini project, you will need to implement some basic features like CRUD operations, create, read, update, and delete. This will allow you to manage tasks or nodes effectively. You will also need a simple database for storing data, which can be done using SQLite. And remember to design your app to be responsive so it works seamlessly across devices. If you are looking to take your project to the next level, you can implement advanced features such as pagination for displaying large amount of data efficiently, user profiles to personalize the experience, or advanced styling with frameworks like Bootstrap to make your app look professional. Once you have built your app, it's time to review the code. Peer reviews are a great way to get feedback and improve your app's quality. Reflect on any challenges you faced during development and think about areas where you can improve, such as error handling, security, or the overall architecture of your app. When you are satisfied with your mini project, make sure to submit the code along with a brief description of your project. You can also include a video or a live link to your deployed app, which will give others a chance to interact with your project. By completing this mini project, you will have gained valuable experience in web development, including both building and deploying a web application. This is an important milestone in your journey as a developer, and I encourage you to continue exploring advanced web development topics such as APIs, security, and performance optimization. Now, let's open the floor for questions. If you have any doubts about the mini project or any aspect of your web development, feel free to ask. I am here to help clarify any concepts or guide you through any challenges you might be facing. Welcome to day 43, Introduction to Machine Learning. In this session, we will cover the basics of machine learning and a dive into the popular libraries that make it easier to build powerful models. First, let's define what machine learning is. Machine learning is a subset of artificial intelligence that enables systems to learn patterns from data and make decisions or predictions without explicit programming. Some real-world applications of machine learning include image recognition, recommendation systems, fraud detection, and autonomous vehicles. There are three main types of machine learning. Supervised learning, where the data comes with labels such as predicting house prices. Unsupervised learning, where the data is unlabeled and the goal is to find hidden patterns like customer segmentation. Reinforcement learning, where systems learn through a trial and error approach, receiving rewards or penalties for their actions, like in game playing algorithms. Machine learning relies on a few key components. Dataset, a collection of data used for training the model. Features and labels. Features are the input variables and labels are the output variables we are trying to predict. Training and testing data. We split the data into training and testing sets to evaluate the model's performance. Evaluation metrics. These are used to access the model's accuracy, precision, recall, and F1 score. Now let's take a look at one of the most popular machine learning libraries in Python, Scikit-learn. It provides a simple interface to build machine learning models with ease. Some of these features include built-in datasets like iris and wine, tools for pre-processing data, and a range of algorithms for training and evaluating models. To install Scikit-learn, you can use pip, the Python package manager. Simply type pip install Scikit-learn in your terminal. Once installed, you can import the library and check the version using print scikit sklearn dot underscore underscore version underscore underscore to ensure everything is set up properly. Let's walk through a basic hands-on example. We will use the iris dataset, which contains data about different types of flowers. First, we load the dataset and split it into training and testing sets. Next, we train a random forest model, and finally, we evaluate its accuracy by checking how well it performs on the test data. Visualization is an important part of understanding your data. For example, we can plot the iris dataset using Matplotlib to see how the different features are distributed. This helps in understanding the relationships between the features and is often the first step in any machine learning task. For further learning, you can check out some great resources. A highly recommended book is Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. You can also visit the official Scikit-learn documentation for guided for detailed guides. Additionally, Free Code Camp offers an excellent YouTube playlist on machine learning. For today's homework, I want you to try out the following. Load and explore another dataset in Scikit-learn, train a logistic regression model, and evaluate its accuracy. Research and write down 5 real-world use cases of supervised learning. Welcome to day 44 of our journey through machine learning. Today we will focus on data preprocessing, a crucial step for preparing data before feeding it into machine learning models. We will dive into cleaning, transforming, and encoding data to improve model performance. Data preprocessing is vital because the quality of the data directly impacts the effectiveness of our machine learning models. Without clean, consistent data, even the best algorithms will struggle. Preprocessing helps us address missing values, reduce noise, and ensure that our data is structured properly, ultimately providing model accuracy and reliability. Data preprocessing typically follows a series of key steps: handling missing values, detecting and managing outliers, converting data types, and addressing imbalanced datasets. Each of these steps helps ensure that the data we use is suitable for training effective machine learning models. Cleaning the data involves handling missing or inconsistent values. For example, if there are missing values in our dataset, we can either remove those rows or fill the gaps with appropriate values such as the mean, median, or mode. This step ensures that our data is complete and ready for model training. Feature scaling and normalization are techniques used to bring the data into a standardized range. For instance, scaling ensures that numerical features are on the same scale, making it easier for algorithms like gradient descent to converge more quickly. Normalization brings all data values within a range like 0 to 1, ensuring that feature, no one feature dominates due to its scale. Many machine learning models require numerical inputs. Hence, we need to encode categorical data such as male or female into numeric values. Common methods include label encoding and one-hot encoding, which convert categories into numerical values while maintaining the integrity of the data. Outliers are data points that deviate significantly from the rest of the data set. We can identify these outliers visually using box plots or scatter plots, or statistically using methods like the z-score or interquartile range. Once detected, we can either remove or adjust these outliers to prevent them from distorting the results. Now it's time to put what we have learned into practice. For this task, we will work with the Titanic dataset. The goal is to clean the data by handling missing values, encoding categorical variables like sex and embark, and scaling numerical features like age and fair. By the end of this task, you will have a dataset ready for building machine learning models. When preprocessed data, always start by analyzing it to understand its structure and identify potential issues. Use pipelines to streamline the preprocessing process, ensuring that steps are applied consistently. And always document your changes so your work is reproducible and transparent. To summarize, data preprocessing is the foundation of building effective machine learning models. It ensures that our data is clean, scaled, and ready for analysis. For your homework, choose a dataset from Kaggle or the UCI machine learning repository, process it, and document your steps. This will help reinforce the techniques we have covered today. Welcome to day 45, Supervised Learning. In today's session, we will dive into the concept of linear regression and logistic regression, two fundamental techniques in machine learning. We will also explore their real-world applications and walk through hands-on examples. Supervised learning is a type of machine learning where we train models on labeled data. This means that the input data comes with known output labels. The goal is for the model to learn from this data so it can predict outcomes on unseen data. A few common examples include predicting house prices or detecting spam emails. In supervised learning, we use the input features to predict an outcome. Linear regression is a technique used for predicting a continuous numerical outcome. For example, we could use it to predict house prices based on features like square footage, number of rooms, and location. This method assumes a linear relationship between the input features and the output. In other words, as the features change, the output changes at a constant rate. In linear regression, we define a model as a linear equation. The model predicts the output based on the input features. The cost function, known as the mean squared error, measures how far off the predictions are from the actual values. We use a method called gradient descent to minimize this error and find the best fitting line. Now let's look at a hands-on example. Suppose we are predicting house prices based on various features. We will start by pre-processing the data, training the linear regression model, and then visualizing the results. With tools like Scikit-learn in Python, we can easily implement this and generate a plot showing how well our model fits the data. Now let's move on to logistic regression. Unlike linear regression, which is used for predicting continuous values, logistic regression is used for classification problems. It predicts the probability of an outcome belonging to a certain class, like predicting whether an email is spam or not. The key function used here is the sigmoid function, which converts the model's output into a probability between 0 and 1. Logistic regression works by calculating the log odds of a certain event and transforming it into a probability. The logistic function or sigmoid function output values between 0 and 1. The model's cost function is cross entropy loss, which measures how well the predicted probabilities match the actual class labels. In a practical example, let's say we are predicting whether a student passes or fails an exam based on study hours. By pre-processing the data and training a logistic regression model, we can classify the outcomes as either pass or fail. Evaluating the model's performance involves looking at accuracy, precision, recall, and other metrics to understand how well it is predicting these outcomes. When building models, we need to be cautious of overfitting and underfitting. Overfitting occurs when the model fits the training data too well, capturing noise and leading to poor generalization. Underfitting happens when the model is too simple to capture the underlying patterns. Regularization techniques like L1 and L2 regularization can help prevent overfitting by adding a penalty to large coefficients. Once we have built our model, we need to evaluate it. A common practice is to split the data into training and test sets to assess how well the model generalizes. We can also use k-fold cross-validation to validate the model's performance by splitting the data into multiple subsets and training the model on different combinations. This ensures that the model performs well across different subsets of the data. In machine learning, the performance of a model can often be improved by tuning hyperparameters. Hyperparameters are the settings that control the learning process, like the learning rate or regularization strength. Methods like grid search and random search allow us to systematically explore different hyperparameter combinations to find the best configuration for our model. Let's put everything together in an end-to-end project. We will load and clean the data, train a model using either linear or logistic regression, and evaluate the results. For example, in a project predicting heart disease, the model could classify patients as either at risk or not based on features like age, blood pressure, and cholesterol levels. To recap, we have learned that supervised learning involves training models on labeled data to predict outcomes. We have covered both linear regression for numerical predictions and logistic regressions for classification tasks. It's essential to practice these concepts through hands-on examples to fully understand how they work and how to apply them effectively. For homework, I recommend implementing linear and logistic regression on new datasets. You can experiment with regularization techniques like the ridge and lasso. I also encourage you to explore Kaggle competitions where you can apply these techniques to real-world problems and further sharpen your skills. Thank you for your time today. I hope you enjoyed this session on supervised learning. Don't hesitate to revisit any of the examples we covered and experiment with them on your own. Welcome to day 46 of our machine learning course. Today we will be diving into the world of unsupervised learning, focusing on clustering techniques and decision trees. By the end of this session, you will have a good understanding of how unsupervised learning can uncover hidden patterns in data. Here's an overview of today's topics. We will begin with an introduction to unsupervised learning and then explore some powerful clustering techniques like k-means, hierarchical, and dbScan. After that, we will take a look at decision trees and their applications in data classification. Finally, we will wrap up with some hands-on practice to solidify your understanding. Unsupervised learning is a type of machine learning where we work with data that does not have labels or predefined outcomes. Unlike supervised learning, where we train the model with labeled data, unsupervised learning allows us to find hidden patterns or groupings in the data. It's ideal for tasks like clustering, dimensionality reduction, and finding with associations between data points. There are three main types of unsupervised learning. First, we have clustering, which involves grouping similar data points together. Second, association helps us discover relationships between variables. Finally, dimensionality reduction simplifies data by reducing the number of features, making it easier to analyze while retaining essential information. Let's start with clustering. Clustering groups data points into clusters based on their similarities. It's widely used in customer segmentation, anomaly detection, and even image segmentation. The goal is to identify natural groupings within the data without needing any predefined labels. One of the most popular clustering algorithms is k-means. The idea behind k-means is simple. We choose a number k for the clusters, randomly assign centroids, and then assign data points to the nearest centroid. We repeat this process, recalculating the centroids until they stabilize. It's a straightforward yet powerful technique for many real-world clustering tasks. Here's an example of how k-means work. We start by selecting k initial centroids, then each data point is assigned to the nearest centroid. Over time, the centroids are updated and the data points are reassigned based on the new centroids. We can determine the optimal k by using the elbow method, which helps identify the best number of clusters for your data. Next, let's talk about hierarchical clustering. Unlike k-means, which divides data into a fixed number of clusters, hierarchical clustering builds a tree-like structure called a dendrogram. This tree shows how clusters are nested within each other, which can be useful for understanding relationships between data points at multiple levels of granularity. Another important clustering method is dbscan, density-based spatial clustering of applications with noise. dbscan is great for handling datasets with noise and irregular shapes. Instead of specifying the number of clusters, dbscan groups points based on density, making it ideal for complex, non-linearly separable data. Now let's shift gears and look at decision trees. Decision trees are a supervised learning technique, but they are incredibly useful in understanding how data can be split and classified. They work by recursively splitting the data based on feature values, with each split maximizing the separation of the classes. This process creates a tree structure with decisions at each node, which makes it easy to visualize and interpret. A decision tree works by splitting the data into subsets based on feature values that best separate the classes. To decide how to split the data, we use metrics like Gini index or entropy, which help determine the quality of the splits. The tree grows until all the data points are classified, and we can prune it to avoid overfitting. Let's now put this into practice. We will use a dataset such as the Titanic survival dataset to build a decision tree. Using a tool like Scikit-learn, we will create a tree that classifies whether a passenger survived or not based on features like age, sex, and class. We can visualize the tree to see how the decisions are made at each step. To reinforce what we have learned, here's your practice assignment. Use a movie ratings dataset to perform clustering and group similar users based on their performances. Once you have created the clusters, analyze the results and try to interpret the patterns in the data. This hands-on experience will help solidify your understanding of supervised learning. To summarize today's lesson, we learned that unsupervised learning helps us discover hidden patterns in data. We explored several clustering techniques like k-means, dbscan, and hierarchical clustering. We also introduced decision trees and their application in classification tasks. Remember, practice is key, so continue experimenting with these techniques to master them. That wraps up today's lesson. If you have any questions, feel free to ask now. I hope you found this session informative and helpful in your journey to understanding unsupervised learning. Thank you for joining, and I will look forward to seeing you in the next session. Welcome to today's lesson on Natural Language Processing or NLP. In this session, we will explore the fundamentals, techniques, and applications of NLP. Let's dive into how machines understand and process human language. NLP is a subfield of artificial intelligence focused on enabling machines to interpret, understand, and generate human language. It's all around us, from chatbots to voice assistants, and even in sentiment analysis for social media. NLP is a key technology driving intelligent systems in today's world. The NLP process follows a series of text steps, starting with data collection, where we gather the text data. Next, we pre-process the data. This includes cleaning and preparing it for analysis. We then extract features, train models, and evaluate them for accuracy. This pipeline is essential for successfully processing and interpreting text in various real-world applications. Let's break down some key text processing steps. First, we have tokenization, where we split text into smaller units like words and or sentences. Then we remove stop words, the common word like is or the that don't carry much meaning. Stemming and lemmatization are the next steps, where we reduce words to their base or root form. For example, running becomes run. This helps simplify the language for processing. There are several ways to represent text data numerically for machine learning models. Bag of words (BOW) is a simple approach where we count the efficiency of each word in the document. Another technique is TF-IDF, which gives more weight to words that are important to specific documents but rare across all documents. Finally, word embeddings like word2vec and glowvec represent words in dense vectors and capture semantic meaning based on context. One common application of NLP is sentiment analysis, where we classify text as positive, negative, or neutral. For example, we can analyze movie reviews to determine if they are favorable or not. Using libraries like NLTK for pre-processing and Scikit-learn for building the model, we can classify sentiment effectively. This helps businesses gauge public opinion on their products or services. Named entity recognition or NER helps us identify and classify named entities in text such as names, locations, and dates. For instance, in the sentence Barack Obama was born in Hawaii, NER will recognize Barack Obama as a person and Hawaii as a location. Tools like SparCY make this process fast and accurate. Let's now look at some best practices. When working with large datasets, like libraries like SPACY are optimized for speed. Handling language ambiguity such as sarcasm or polysemy is one of the biggest challenges in NLP. Additionally, dealing with multilingual data or non-standard text like slang requires robust models and data processing techniques. Despite the advancements, there are several challenges in NLP. Poor quality or noisy data can lead to inaccurate results. Contextual understanding is another hurdle, especially when dealing with ambiguous meanings in language. Lastly, multilingual NLP requires special techniques to work effectively across languages, making it a complex task. If you are looking to dive deeper into NLP, some excellent resources include libraries like NLTK and SPACY. Spacey. You can also practice on publicly available datasets such as the IMDb movie reviews or Twitter sentiment analysis dataset. Platforms like Kaggle offer real-world NLP challenges, and Google Colab provides an easy way to run your models in the cloud. To summarize, natural language processing helps machines understand and interpret human language. We covered techniques like tokenization, stopword removal, stemming, lemmatization, TF-IDF, and word embeddings. These tools are used in various applications including sentiment analysis and named entity recognition. Next steps: start experimenting with NLTK and Spacey to build your own NLP models. That wraps up today's lesson on NLP. If you have any questions or would like further clarification on any of the topics, feel free to ask now. I would be happy to help. Welcome to day 48 of our journey into deep learning. In today's session, we will dive into the basics of neural networks and explore how to use TensorFlow and Keras for building deep learning models. Deep learning is a subset of machine learning that utilizes neural networks with multiple layers. It allows computers to learn from large amounts of data, enabling them to perform complex tasks like image recognition, space recognition, and even self-driving cars. Deep learning powers many of the advanced AI systems we use today. A neural network consists of several key components. The input layer is where data enters the model. The hidden layers are responsible for processing the input, extracting features, and learning from the data. Finally, the output layer produces the prediction or classification. We also use activation functions such as ReLU, sigmoid, or softmax to introduce non-linearity, allowing the network to learn more complex patterns. Forward propagation is a process where input data is passed through the network to make predictions. Each neuron in the network performs a weighted sum of the inputs, adds a bias, and passes the result through an activation function to produce an output. This is how the model makes predictions based on the data it has seen. Backward propagation or backpropagation is a process of adjusting the weights and biases in the network based on the error or loss. It works by calculating the gradient of the loss function with respect to each weight and then using optimization algorithms like gradient descent to update the weights. The goal is to minimize the error and improve the model's accuracy. TensorFlow is a powerful open source library developed by Google that facilitates building and training deep learning models. Keras is a high-level API that sits on top of TensorFlow, providing an easy-to-use interface for constructing complex neural networks. Today, TensorFlow and Keras make deep learning accessible and efficient. To get started with deep learning, we need to install TensorFlow and Keras. Simply open your terminal and type pip install TensorFlow. We recommend using Python 3.x and a Jupyter Notebook environment for an optimal development experience. Once set up, we are ready to build our models. Let's dive into building our first simple neural network. We will use the MNIST dataset, which contains images of handwritten digits. Before training the model, we pre-process the data by normalizing the images and reshaping them to fit the model's input requirements. Our network will have one or more hidden layers and an output layer with 10 nodes, corresponding to the 10-digit classes. Here's a basic example of how to build a neural network using TensorFlow and Keras. First, we import the necessary modules. Then we load the MNIST dataset and normalize the data. Next, we define the model architecture using Keras sequential API, adding layers like flatten, dense, and the output layer with a softmax activation function. Finally, we compile the model, specifying the optimizer, loss function, and evaluation metrics and train it with the training data. Once our model is defined, we train it using the training dataset with model.fit. This process adjusts the model's parameters to reduce error. After training, we evaluate the model on the test dataset using model.evaluate. The evaluation gives us an understanding of how well the model generalizes to new unseen data with metrics like accuracy and loss. Overfitting occurs when the model performs well on the training data but poorly on new unseen data. To address this, we can use techniques like dropout layers or regularization. Underfitting happens when the model is too simple and doesn't capture the underlying patterns in the data. In this case, we can increase the model's complexity or provide more data to help it learn better. Now let's put our knowledge to practice. We will build and evaluate a neural network on the MNIST dataset. As we train the model, we visualize the accuracy and the loss curves to monitor the model's progress and performance. Today, we learned the fundamentals of deep learning and neural networks. We explored the structure of a neural network, the processes of forward and backward propagation, and how to use TensorFlow and Keras to build models. We also touched on strategies for handling common performance issues like overfitting and underfitting. Thank you for your attention. I would now like to open the floor for any questions or clarifications you may have. Welcome to this mini project on building a basic machine learning model. In today's session, we will walk through the steps of applying machine learning concepts to a real-world problem. Specifically, we will build a spam email classification model covering data pre-processing, model training, evaluation, and deployment. The primary objective of today's mini project is to create a simple machine learning model. We will apply the concepts we have learned over the past few weeks, focusing on real-world applications like spam email classification. By the end of the project, you will understand the full pipeline of machine learning from data pre-processing to model deployment. Let's start by defining the problem. For this mini project, we will be working on a spam email classification task. Our dataset will include features such as email content, sender, and subject, and the goal is to classify each email as either spam or not spam. By building this model, we will learn how to handle and process real-world data efficiently. Before we dive into training the model, we need to pre-process the data. This includes handling any missing values by fitting or removing them. Feature scaling is crucial to ensure that all the features are on the same scale, and we will also need to encode any categorical variables to numeric values. This is where we will use tools like Python's Pandas and Scikit-learn to clean and prepare the data for modeling. Once the data is pre-processed, we can move on to selecting and training a model. For this mini project, we will use supervised learning, specifically algorithms like logistic regression or decision trees. We will split the data into training and testing sets and then train our model using Scikit-learn. To optimize performance, we will also experiment with hyperparameter tuning. After training the model, we will need to evaluate its performance. We will look at several key metrics such as accuracy, precision, recall, F1 score, and ROC AUC. These matrices will help us understand how well our model performs, especially on imbalanced classes like spam versus not spam. We will also generate a confusion matrix to see where the model is making errors. To improve the model, we will compare different algorithms and see which one performs better. We might also tune the model's hyperparameters or try additional feature engineering. Documenting the results and identifying areas for improvement is an essential step in ensuring that the model performs at its best. Once we have trained an evaluated model, we need to deploy it. We will save the trained model using Python's joblib or pickle, which will allow us to reuse it in the future. Optionally, we can create a simple app using Flask or Streamlit to make real-time predictions on new data. Documentation is an important part of the project. It should include details about the dataset, pre-processing steps, model selection, and the performance evaluation. It's also crucial to document how to use the model for predictions. In summary, we have covered the entire machine learning pipeline, from data pre-processing and model training to evaluation and deployment. That wraps up the mini project on building a basic machine learning model. Do you have any questions or comments? Feel free to ask, and I would be happy to clarify anything you might be uncertain about. Welcome to the presentation on day 50 of the Capstone project. Today we will be focusing on project planning and requirement gathering, laying the groundwork for a successful project. Let's get started. On day 50, we set the stage for our project by defining clear objectives. First, we need to select a project theme. You can choose between the three options: web scraper, data analyzer, or machine learning model. Next, we define the project's goals and outcomes. These goals should be clear and measurable. We also gather the requirements, including tools, libraries, and data sources, and lay out a project plan with milestones for coding, testing, and debugging. If you choose to work on a web scraper, the objective is to automate data extraction from websites. The outcome would be clean datasets exported in formats such as CSV or JSON that can be used for further analysis. Alternatively, if you choose the data analyzer, the objective is to analyze datasets and extract actionable insights. The outcome would be comprehensive analytical reports and compelling visualizations of the data. For those selecting an ML model, the objective is to build a predictive model for a specific problem domain, such as classification or regression. The outcome would be trained models with performance metrics that demonstrate the effectiveness of the model. Moving forward, we begin gathering the necessary requirements. For a web scraper, we will need tools and libraries such as BeautifulSoup, Scrappy, or Selenium. We will also need to identify the websites or APIs from which we will scrap data. For a data analyzer, we will utilize libraries such as Pandas, Matplotlib, and Seaborn for data manipulation and visualization. The datasets can be sourced from public repositories like Kaggle or UCI. For the ML model, we will use libraries like Scikit-learn or TensorFlow. The data sources will be labeled datasets, which will be pre-processed before training the model. We will define inputs and outputs clearly to ensure smooth execution. Here's a high-level project overview. The plan is to divide it into several phases with milestones for each. We start with planning, moving to data collection, followed by development, testing, enhancements, and finally, finalization. Each phase is aligned with specific tasks and days. While planning for the web scraper, we must consider potential risks. This includes website restrictions or data unavailability, which can cause delays or affect data collection. For the data analyzer, risks may arise from incomplete or noisy datasets, which can lead to misleading insights or errors in analysis. Through data cleaning, though data cleaning is key to mitigating this risk. Similarly, for the ML model, challenges may include poor model performance or overfitting. To mitigate this, we can use cross-validation techniques, fine-tune hyperparameters, and ensure that training data is representative of the problem domain. As we reach day 50, we define the preliminary deliverables. By the end of the day, we should have the project proposal, the requirements document, and the project timeline, including milestones for all phases of the project. Thank you for your attention. If you have any questions or need further details, feel free to contact me. Remember, planning is the foundation of success, so let's get started on the right foot. Welcome to day 51, Data Collection and Preparation. Today, we will focus on preparing data for web scraping, data analysis, and machine learning projects. Let's dive into the crucial steps required to set up the foundation for your project. The objective for today is to acquire and pre-process data. This ensures that the data is ready for analysis or modeling. Whether you are working with web scraping, analyzing data sets, or building a machine learning model, cleaning and organizing your code is essential for reliable results. Here's a quick overview of the areas we'll be focusing on. Web scraper. We will learn how to extract and clean data from websites. Data analyzer. We will cover how to locate, clean, and explore datasets. ML model. We will prepare data for training and evaluation in machine learning models. For the web scraper, we will first set up scraping tools like BeautifulSoup, ScrapPy, or Selenium. After that, we will inspect the target website's structure to understand how to extract the data. Writing the initial scripts will allow us to collect sample data, and we will handle challenges like dynamic content and captchas. Finally, we will clean the data and store it for later use. For data analysis, we start by locating reliable datasets for sources like Kaggle or UCM. Once we have the data, we will clean it by handling missing values, removing duplicates, and ensuring consistent formats. Next, we will perform exploratory data analysis or EDA to analyze the data's distributions and correlations. Finally, we will visualize insights using tools like Matplotlib and Seaborn. For building an ML model, the first step is collecting and splitting the data into training, validation, and testing sets. After that, we will pre-process the data by normalizing numerical features and encoding categorical variables. We will also address any data imbalance using techniques like S-mode or undersampling to ensure balanced data for model training. Across all project types, there are some common tasks to ensure success. First, we will document each step of the process from data collection to pre-processing. It's also important to back up the data using Git or cloud storage. Finally, visualizing insights not only helps with analysis but also ensures transparency and supports decision making. By the end of day 51, you will have completed several important deliverables, scrapped or downloaded datasets, cleaned and pre-processed data that's ready for analysis or modeling, well-documented steps covering data sources, cleaning and pre-processing methods. Now that the data is ready, we can move on to the next step, core functionality implementation. This will begin on day 52. We have laid the groundwork and now it's time to build and experiment. Let's get started. Welcome to day 52, core functionality implementation. In this session, we will explore how to build the foundation for your project, whether it's a web scraper, data analyzer, or machine learning model. Let's get started. Today's objective is to develop and test the core functionality of your project. The focus will be on ensuring that your implementation is in line with your project goals and that is modular, reliable, and scalable. We will dive into each type of project and understand the steps involved in building the core features. Every project will have different core functionalities. For a web scraper, the focus is on automating data extraction and handling dynamic content. For a data analyzer, it involves cleaning the data and generating insights through visualizations. And for a machine learning model, we build a pipeline to train and evaluate models, experimenting with different algorithms to achieve the best results. Let's start with a web scraper. The first task is writing scripts to extract data using tools like BeautifulSoup, Scrappy, or Selenium. It's important to handle dynamic content and pagination properly. Then we clean and standardize the data, storing it in a database like SQLite or MySQL, or exporting it as CSV or JSON. Testing is crucial, especially for handling edge cases like broken links or rate limits, and error handling should be implemented to retry failed requests. Next, for the data analyzer, the first step is to load and validate your datasets. This could come from sources like Kaggle, UCI, or public APIs. Once loaded, data cleaning follows, where we handle missing values, outliers, and format conversions. Then we perform exploratory data analysis (EDA) using tools like Pandas, Matplotlib, and Seaborn to generate insights and visualizations. The goal is to detect patterns, trends, and statistical relationships within the data. For the machine learning model, we begin by preparing the data. This involves normalizing, encoding categorical variables, and splitting the data into training, validation, and test cases. We then implement the ML pipeline, which includes loading the data, training the model, and evaluating performance. Various algorithms can be experimented with, like linear regression or decision trees, to find the best fit. Testing and debugging are crucial, especially when addressing outfitting or underfitting issues. Across all project types, there are few common best practices. Logging and monitoring progress are essential for debugging. Version controlling Version control using Git helps in code management and collaboration, ensuring that all team members are on the same page. Additionally, backing up raw data and results is vital to avoid data loss, and automating periodic checkpoints will help in keeping track of progress. To summarize, day 52 focuses on implementing the core functionality of your project. Whether you are working on a web scraper, data analyzer, or machine learning model, the key takes that key tasks involve writing scripts, cleaning data, testing, and ensuring scalability. By following these steps, you will lay the groundwork for a solid and reliable project. Hello and welcome to this presentation on testing and debugging for Capstone project. In this session, we will walk you through essential testing strategies, debugging common issues, and ensuring the reliability and robustness of your project. Let's start with the agenda. Today we will cover key aspects of testing and debugging, including planning your testing strategy, conducting unit and integration tests, handling common issues, and testing edge cases. We will also discuss automation, logging, performance, stress testing, and how to prepare a comprehensive debugging support. To begin, it's important to plan your testing strategy. This involves deciding the types of tests you need, such as unit testing, integration testing, and system testing. You should also prepare for edge case testing, where we identify scenarios that could potentially break the system. With a well-structured plan, you ensure that every component works as expected. Unit testing helps ensure that individual components of your project work correctly. By testing each function independently, you can catch issues early in the development process. Tools like unittest or pytest are often used for writing and running unit tests. For example, in a web scraper, we should test the HTML parsing function, while in a data analyzer, we test data preprocessing methods. Integration testing ensures that different modules of your project interact correctly. After validating individual components, it's crucial to check if they work well together. For instance, in a web scraper, you want to test if data is fetched, parsed, and saved seamlessly. Similarly, in a data analyzer, you need to ensure data flows smoothly from cleaning to visualization. Debugging common issues is a critical aspect of testing. For a web scraper, data fetching inconsistencies like timeouts or incorrect HTML structure can occur, but we can fix them with retry mechanisms or dynamic parsing. In data analysis, we may encounter incorrect visualizations, which can be addressed by validating data transformations before plotting. For ML models, you might face poor performance or overfitting, which can be tackled through feature importance analysis and model tuning. Edge case testing is vital in uncovering unexpected behaviors or failures. For instance, what happens when the input data is empty or malformed, or when the network connection for a scraper is interrupted. By testing these edge cases, we make sure your system is robust and can handle all types of real-world scenarios, even the unexpected ones. Automation plays a key role in efficient testing. Tools like GitHub Actions or Jenkins can automate your testing process, ensuring that tests are run continuously and consistently. Additionally, logging helps track the performance and issues during testing. By implementing structured logging, you can capture important details that will help in debugging and improving the system. Performance and stress testing help evaluate how your system performs under heavy loads. For a web scraper, this means testing how the system behaves with multiple concurrent requests. For a data analyzer, we assess its performance when dealing with large data sets. In machine learning models, it's crucial to test training time and scalability to ensure the model can handle bigger data as it scales. A debugging report is essential for summarizing the testing process. This report should outline the test cases, results, and any fixes made during the testing phase. It's also important to highlight key issues and the steps taken to resolve them. Including logs or screenshots can help further document the issues and the solutions applied. In conclusion, comprehensive testing is critical for ensuring a reliable, robust system. By focusing on unit tests, integration tests, and edge case scenarios, we can address most issues early. Debugging common issues and automating tests will streamline your process, while performance and stress testing will ensure your system can handle real-world challenges. Ultimately, a strong debugging report helps communicate progress and areas for improvement. That concludes our presentation on testing and debugging. I hope this session has helped you understand the importance of a well-structured testing strategy and the techniques for ensuring your project's reliability. Feel free to ask any questions or share your thoughts on the topic. Welcome to the presentation on enhancing features. In this session, we will focus on the advanced features, optimizations, and usability improvements you can implement for your project on day 54. Let's dive in. The objective of day 54 is to improve the functionality and usability of your project. You will cover enhancements across three areas: web scraping, data analysis, and machine learning. Our goal is to make the project more robust, user-friendly, and scalable. Starting with the web scraper, one of the primary enhancements we can implement is better data storage. You can integrate database support by using lightweight databases like SQLite or choose scalable solutions like MySQL or PostgreSQL. Additionally, allowing your scraper to export data in CSV, JSON, or XML formats will improve data accessibility and usability. Next, let's focus on error handling and logging. Implementing graceful error handling for network issues like 404s or 500s is essential. Using retry mechanisms we exponential with exponential backups, we ensure that your scraper is resilient. Additionally, utilizing Python's logging module will help you track issues and monitor scraper performance. In terms of feature enhancements, you can make your web scraper more efficient by supporting dynamic content through tools like Selenium or Puppeteer. Consider integrating multithreading or asynchronous scraping for faster data extraction. And don't forget about scheduling periodic scraps so you can gather updated data regularly without manual intervention. While not essential, adding a user interface can greatly improve the experience. A simple command line interface or even a web interface would allow users to specify target websites, define scraping parameters, and select output formats. This makes your tool more flexible and accessible. Moving on to the data analyzer, one of the first improvements is modularization. By breaking down tasks into data cleaning, trend analysis, and visualization into reusable modules, you can make your code cleaner and more maintainable. Automating these tasks will save time and ensure consistency across different analyses. To enhance the visualizations, consider integrating interactive plots using libraries like Plotly or Dash. This will allow users to explore the data dynamically. Additionally, you can add functionality to export this visualization as static images or interactive HTML files, making it easier to share and present insights. To take your analysis a step further, you can implement advanced analytic features. For example, you can use regression models for predictive analysis or time series forecasting. You could also apply clustering techniques like k-means to discover hidden patterns in the data. Another useful addition is anomaly detection to identify outliers or unusual trends. Feature enrichment involves adding the ability to work with multiple datasets simultaneously. By comparing datasets, you can find new insights that might not be obvious from a single source. You can also automate the generation of reports, summarizing your findings and presenting them in a consistent format. Shifting focus to the machine learning model, optimizing your model is crucial. Experimenting with different algorithms can help you find the best fit for your problem. For classification tasks, you could try random forest, SVM, or neural networks, while regression tasks can benefit from algorithms like SGBoost or LightGBM. Hyperparameter tuning using tools like Grid Search CV and Randomized Search CV can further improve accuracy. Another key enhancement is model persistence. After training your model, it's important to be able to save it so you don't have to retain every time you want to make predictions. You can use libraries like JobLib or Pickle to store and load your models. Feature engineering is a powerful way to improve your model's performance. By creating derived features specific to your problem, you can provide more useful data for training. Additionally, feature selection techniques like PCA or mutual information can help you reduce dimensionality and focus on the most important variables. Machine learning models can often be black boxes, but it's important to make them more interpretable. By using tools like Shape or Lime, you can explain your model's predictions and understand which features have the greatest impact. This makes your model more trustworthy and easier to debug. Scaling and deploying your machine learning model is the final step. Batch predictions will allow you to handle large datasets more efficiently. Additionally, deploying your model as an API using frameworks like Flask or Fast API makes it easier to integrate with other applications and services. Beyond the specific enhancements for each area, there are general improvements you can make for all types of projects. Ensuring clean, optimized, and modular code will make your project easier to maintain and scale. Improving user experience, whether through better interfaces or real-time progress updates, is also key. And don't forget to focus on testing. Adding test cases and performance benchmarks will ensure your project remains reliable. In conclusion, day 54 is about enhancing the functionality and usability of your project. By implementing these advanced features and optimizations, you will improve both performance and user experience. The next steps include final testing, documentation, and preparing your project for deployment or presentation. Thanks for listening and best of luck with your enhancements. Welcome to the presentation on the finalization and documentation phase of the Capstone project. In this session, we will go over the key steps taken to wrap up the project, ensure its completeness, and prepare it for handoff. The objective of day 55 is to prepare the project for handoff, presentation, and future refinements. This includes ensuring that the project is fully documented, functional, and ready for review. First, we focus on code finalization. This step involves organizing the code into consistent naming conversions and clear directory structures. We also clean up the code by removing unused sections and replacing hard-coded values with configuration files. Refactoring into modular functions and reusable classes is key to ensuring that the code is both efficient and acceptable. Next, we turn to documentation. A strong project overview outlines the purpose and goals of the project, as well as the tools and libraries used. An installation guide ensures that the project can be set up easily, while a user manual provides step-by-step instructions for running the project and troubleshooting common issues. Code documentation is crucial for clarity. Inline comments help explain complex sections of code, and docstrings provide detailed descriptions for each function or class. For projects with APIs, automated documentation tools like Sphinx can, can be used to generate detailed references for developers and users. Testing and quality assurance ensure the reliability of the project. We finalize unit tests to check individual components and perform integration testing to verify that everything works together. Additionally, performance metrics like accuracy and runtime are measured, and we test for edge cases to handle any unexpected errors. Looking ahead, we outline potential enhancements for the project. This includes a roadmap for future features and improvements, ensuring that the project remains adaptable for new use cases. By making the code modifiable and future-proof, we ensure its long-term viability. Preparation for the presentation involves creating a concise summary report that covers the project objectives, implementation details, and outcomes. A clear slide deck with visuals and key findings helps present the work effectively. Additionally, a demo video or live demonstration allows the audience to see the project in action. The project repository needs to be clean and organized. We ensure that the repository uses proper version control practices such as .gitignore for irrelevant files and a detailed readme.md for easy navigation. If applicable, we deploy the project, making sure that deployment instructions are documented for future references. Feedback and viewing are essential to refine the project. We gather peer feedback to identify areas for improvement and integrate these suggestions into the final deliverable. Final validation ensures that all features work as intended and meet the original project goals. In conclusion, by following these steps, we ensure that the project is polished, well documented, and ready for handoff. The final deliverable is now in a state that's ready for submission, peer sharing, or deployment for broader use. Thank you for following along. Welcome to the presentation on refining the project as part of the Capstone project phase 2. In this phase, we focus on enhancing the functionality, code quality, and performance of our project. Today, our objective is to refine and optimize the project, ensuring it is both robust and functional. We will revisit core functionalities from phase 1, improve code quality, and address key areas like edge cases and performance. To begin, we need to review the core functionalities that we implemented in phase 1. This involves revisiting the initial requirements, evaluating success criteria, and incorporating feedback to ensure everything is working as expected. We also identify any gaps and address them before moving forward. Next, we focus on improving the code quality. This means refactoring code to make it more readable, modular, and maintainable. We will improve the structure, use better naming conventions, and eliminate any redundant operations. Additionally, we optimize performance by reviewing algorithms and managing memory more effectively. Let's dive into the web scraper. One important aspect is handling edge cases. For example, we will ensure that timeouts are managed effectively with retry strategies. We also need to handle rate limiting from websites and ensure the scraper can handle multiple pages such as pagination seamlessly. For the data analyzer, we will add advanced features like correlations to analyze relations between different variables, trend analysis to detect patterns, and forecasting using techniques like ARIMA for predictions. These improvements will make the data analysis more insightful and valuable. Turning to the machine learning model, we aim to enhance its performance. This involves using cross-validation for more reliable results and regularization to avoid overfitting. Additionally, we will focus on feature engineering, which helps to improve the accuracy of the model. We will also experiment with hyperparameter optimization using techniques like grid search. Testing is critical at this stage. We will conduct regression tests to ensure that no issues have been introduced while refining the project. Furthermore, we will automate our tests to streamline the process and identify any new areas for improvement in both functionality and performance. Usability testing will help us gather valuable feedback from peers or external testers. The focus will be on performance, ease of use, and overall user experience. Based on this feedback, we will refine the project further and document any changes or performance improvements. As we look ahead to day 57, we will focus on UI enhancements or further improving the model's capabilities. We will also finalize any remaining refinements in preparation for the final presentation and submission of the project. In conclusion, day 56 is all about refining the project's functionality, optimizing performance, and enhancing code quality. We have ensured that the project is ready for the next phase with attention to detail and a focus on delivering a high quality product. Hello and welcome to day 57 of our Capstone project. Today we will focus on adding a user interface or enhancing the performance of the machine learning model. In this session, we will explore how to refine both the web scraper and data analyzer as well as improve the machine learning model. Let's dive in. Here's a quick overview of today's agenda. We will start by enhancing the web scraper and data analyzer with a web interface and improve data visualizations. Then we will shift focus to the machine learning model, where we will experiment with more advanced algorithms, fine-tune hyperparameters, and evaluate model performance. Let's break down each of these topics. Our first step is enhancing the web scraper and data analyzer with a web interface. This will allow users to interact with the project more easily. The plan is to integrate a front-end using Flask or Django, where users can input parameters for scraping or analysis. and view the results. We will build simple forms to accept user inputs and display the results clearly. To make the web interface even more user-friendly, we will ensure proper form handling by validating user input. We will also make sure the results are displayed in a neat and organized manner, allowing users to download the data or analysis results as needed. Next, we will enhance the data visualization. The goal is to present the data in a way that's both informative and engaging. We will use libraries like Plotly, Dash, or Streamlit to create dynamic graphs and charts. This will allow users to track the progress of the scraper or observe trends in the data with interactive elements. To further improve the user experience, we will add interactive filtering and sorting features. This will allow users to filter the results based on specific criteria and sort them dynamically, whether by date, category, or any other parameter they choose. Let's now turn our attention to the machine learning model. Our objective here is to improve model performance. To do this, we will experiment with advanced algorithms like random forest, XGBoost, or even neural networks. We will also fine-tune the hyperparameters using grid search CV or randomized search CV for optimal performance. Fine-tuning the hyperparameters is a crucial step in ensuring that our model generalizes well. We will explore the hyperparameter space to find the best configuration and apply techniques like k-fold cross-validation to make sure the model performs well on unseen data. We will also address overfitting or underfitting by adjusting model complexity and regularization techniques. Once we have fine-tuned the model, it's time to evaluate its performance. We will use a variety of metrics such as accuracy, precision, recall, and AUC/ROC for classification problems. For regression models, we will look at metrics like MAE or RMSE. We will also test the model with real-world data to assess its practical performance. To ensure that the model is scalable and robust, we will focus on optimization. This includes addressing overfitting and underfitting, improving regularization, and testing how the model performs under larger datasets or high user loads. Our goal is to create a model that can handle growth in both data and user interaction. After refining the model, it's time for deployment. We will serialize the model using tools like Pickle or JobLib and integrate it into our web interface for real-time predictions. This will allow users to interact with the model and receive predictions directly from the interface. By the end of day 57, our key deliverables will include a fully functional web interface for user interaction, dynamic and interactive data visualization, and a significantly improved machine learning model. We will also have a clear and organized system for model evaluation and optimization. In summary, we have enhanced the user interface, improved model performance, and optimized the entire system for better usability and scalability. Our next steps will involve further refinement in the final phase, followed by preparing for project delivery and presentation. Thank you for joining me today. Welcome to day 59, Final Testing and Debugging. In today's session, we will focus on finalizing your project by thoroughly testing and debugging it. We will ensure that the project is stable, optimized, and ready for deployment. You will also learn how to write effective test cases to validate your work. Let's start with final debugging. First, we will review and refactor the code. This means optimizing for better performance, readability, and removing redundant or inefficient code. Next, we will address any bugs that arise using debugging tools to pinpoint errors. Pay close attention to error logs and tracebacks to identify and fix issues. Finally, we will test for edge cases and check for any vulnerabilities that could affect the system's reliability. Now let's talk about unit testing. Unit tests help verify that individual components of your system work as expected. You will write tests for each function or method using frameworks like JUnit for Java or PyTest for Python. By providing known inputs, we can check if the system produces the expected results. This ensures that your functions behave correctly in isolation before integrating them into the full project. After unit testing, we move on to integration testing. This is where we test how different modules work together. It's crucial to ensure that data flows smoothly between modules and the system works as a whole. Integration testing helps identify issues that may arise when components interact, which might not have been apparent in individual tests. Next, we will look at user interface testing. The UI is what users interact with, so it's essential to ensure it's both functional and intuitive. We will test the responsiveness across different screen sizes and browsers, ensuring that the interface adapts well. Additionally, we will simulate user actions like button clicks or form submissions to make sure everything works as intended, providing a seamless user interface. Performance testing is another crucial step. Here we test the system's ability to handle various loads like large amounts of user traffic or data. Stress testing will help determine how the system performs under heavy usage, while optimizing for performance ensures that responsive times and resource consumption are efficient. You will also identify any performance bottlenecks and resolve them to ensure the system remains stable under load. Once testing is complete, it's time for the final bug fixes. During this stage, we address any critical issues that were identified in earlier testing. This is your chance to clean up any remaining glitches or unexpected behavior. After fixing the bugs, we will do a final pass to ensure the system is fully stable and ready to release. Writing test cases is essential to the testing process. You will start by creating a test plan that outlines all the types of tests you need to conduct, from functional tests to performances and security tests. Each test case should have a clear objective, and you should write tests for specific scenarios and edge cases. Automating your tests makes the process faster and more efficient, ensuring you can quickly identify any issues. Testing user scenarios ensures that the system performs correctly in real world situations. Think about how users will interact with your application. Actions like registration, payments, or even error handling should be tested. Regression testing is also important to make sure that new changes don't break previously working features. Once all the test cases are written, it's time for test execution. You will run all the tests to validate the system's functionality across various conditions. Document the results and ensure you fix any failing tests. Test coverages Test coverage is crucial. Make sure that all critical paths and edge cases are covered to guarantee the robustness of your system. To conclude, by the end of day 59, your project should be fully tested, debugged, and optimized. You will have a stable system that is ready for deployment. With proper test cases, you ensure long-term reliability and robustness. It's now time to conduct a final review and prepare for the next steps in your project journey. Welcome to the final day of our course. Today we will be reviewing all the key concepts we have covered and discussing the next steps in your learning journey. Let's dive in. As we wrap up the course, let's take a moment to recap the essential concepts we have covered or explored. We begin with the basics, progressing to more advanced topics and practical applications. Along the way, we worked on hands-on projects that reinforce these concepts. Today's review will help us understand the key takeaways and how they fit together. Here's a visual summary of the topics we have covered. From the foundational skills to the advanced techniques, everything is interconnected. By looking at this map, you can easily recall the key concepts and how each one builds upon the next. If you have any questions or need clarification, feel free to ask during our interactive review. Now that you have completed the course, it's time to continue learning. I highly recommend checking out these resources to dive deeper into the topics we have covered. For books, consider Clean Code by Robert C. Martin and Design Patterns by Erich Gamma. You can also explore advanced courses on platforms like Udemy or Coursera. Don't forget to refer to official documentation for further reading and join online communities like Stack Overflow and GitHub for continued support. One of the best ways to solidify what you have learned is by building your own projects. Not only will this help reinforce the concepts, but it will also give you real-world experiences. Start with projects that interest you, like creating a personal website or a simple app. Remember, building a portfolio and using GitHub to track your progress will help you stand out to future employers or clients. I want to leave you with a few words of motivation. Embrace a growth mindset, keep learning, keep challenging yourself, and always practice what you have learned. Networking is equally important, so be sure to attend meetups, participate in hackathons, and stay active in the developer community. Finally, celebrate your achievements. You have done great so far, and there's so much more ahead of you. As we come to the end of this course, I would like to thank each of you for your dedication and hard work. Remember, learning does not stop here. Keep pushing forward and applying the skills you have acquired. If you have any feedback or need additional support, I would love to hear from you. Don't forget to stay connected. Now it's time to take the next step in your journey. Join our community forum for ongoing discussions and support. Keep building, experimenting, and growing. I wish you the best of luck on your learning path, and I am excited to see what you create next. Thank you and good luck. Welcome to the conclusion of the final Python Mastery course. Congratulations on completing this journey from beginner to advanced Python developer. In this video, we will recap everything we have learned and explore the next steps in your Python journey. Over the past 2 months, we have built a solid foundation in Python programming, from understanding the basic syntax and data structures like lists and dictionaries, to mastering object-oriented programming and advanced topics like machine learning and deep learning. You have covered a lot. We have worked on real world projects like a bank account system and a web scraper, giving you practical experience in Python that will serve you well in future endeavors. So, what's next? Keep pushing your skills further by building personal projects. The more you practice, the more you will improve. Dive deeper into advanced topics such as machine learning or web development frameworks like Flask and Django. You can also contribute to open source projects, which is a great way to collaborate with other developers and enhance your skills. Finally, start applying for Python development roles or internships. Is the perfect time to take the next step in your career. Stay connected with the Python community, join Python meetups, engage with fellow developers online, and keep learning by following Python blogs and influencers. The tech world is constantly evolving, and staying informed will help you stay ahead. Make sure to subscribe to my channel for more tutorials and advanced Python topics. I will be covering new concepts, real-world projects, and Python libraries that will keep you on the cutting edge of development. Don't forget to leave your feedback in the comments and ask any questions you may have. I am here to help. And finally, thank you. Thank you for being a part of this course, for your dedication, and for taking the time to master Python. I hope you have found this journey valuable and are ready to tackle even more challenging projects ahead. Happy coding, and I wish you all the best on your Python adventures.